Today, we will have the opportunity to hear from each of our country project leaders. Our project leaders and their respective teams have faced a great challenge in the start of this phase of the project. However, they have adapted and overcome obstacles to continue making progress towards our goals. We will first hear from ASMC Director, Dr. Prasanta Kalita. He will be followed by Dr. Vara Prasad, the Program Director for the Feed the Future Innovation Lab for Collaborative Research on Sustainable Intensification. Next, University of Illinois President Emeritus Robert Easter will present today's keynote speech. We will then hear from our Asia Regional Coordinator and our West Africa Regional Coordinator, and they will be introducing our country project leaders. Each project leader has provided a presentation, and each presentation will have a 10-minute question and answer period that will follow the presentation. After our second break, we will hear from Dr. Niroj Aryal from North Carolina A&T, and Dr. Ranjani Krishnan and Dr. Alan Hansen will then present their work on the scaling gap analysis and the technology readiness assessment. Maria Jones, our ASMC gender specialist, will then share her presentation. The ASMC Youth Engagement Specialist, Dr. George Czapar, will then share his presentation. And in this presentation, we will hear from a special guest, Dr. Samantha Lindgren, who has conducted a research survey on youth engagement in Cambodia, and she will be sharing her findings. We will then hear from Dr. Kalita one last time for some closing remarks before we adjourn for the day. I would like to note that this session at the end of the meeting will be a closed session, and this meeting will only be between the ASMC Science Advisory Committee, project leaders, ASMC managing entity, and the Science Advisory Committee, of course. Before I introduce Dr. Kalita, I would just like to say thank you again to all of you who have joined us today. If you have any issues throughout the course of the event, you are welcome to directly message myself or Aditya Meena, who will be assisting me. And I hope that everyone enjoys the meeting. At this time, I would now like to introduce the Appropriate Scale Mechanization Consortium Director, Dr. Prasanta Kalita. Dr. Kalita is a professor of agricultural and biological engineering and a presidential fellow of the University of Illinois System, a fellow of the American Society of Agricultural and Biological Engineers, and the Indian Society of Agricultural Engineering. His research areas include water resources management and environmental sustainability, food security, and water quality. Dr. Kalita is widely recognized for his excellence in teaching, research, and international engagement. He has worked extensively in educational development and capacity building, water resources, food production, and food security issues around the world. Dr. Kalita, we're very honored that you are our director, and the floor is now yours.
Thank you, Leighton. Thank you very much. Good morning, everybody. I really thank each and every one of you from the bottom of my heart. You are participating in the meeting from all across the globe. And I know our time is 7 o'clock, but some of your times are way on the other side, even maybe the different dates, especially from Japan and all out there. So I'm so grateful that you all are participating. And I hope this will be an exciting meeting for all of us to learn from each other and especially learn from our country directors. Is my presentation showing in the presentation mode? It's now on the mode.
There you go.
Okay. So I will be giving a very brief overview of the ASMC and the details of our specific activities will be presented by our colleagues and partners from our countries in Asia and Africa, as well as our US partners from Illinois and elsewhere. So first of all, I would like to, again, as Leighton mentioned, I like to thank, and we are our founder, United States Agency for International Development, and Dr. Jerry Glover is the our link for the project through Dr. Vara Prasad. So it's on the Feed the Future initiative, and Professor Vara Prasad from Kansas State University, he has put together several teams, and you will hear from him a little later, right after me, give you the overall, the Sustainable Intensification Innovation Lab overview and tell about the overall goal. So we are part of the several consortiums that Dr. Prasad has put together. So we will not be able to do all this work without Leighton's help. Leighton, as you know, many of you have met him or gotten his emails and be bothered by him and all those kind of things. But without his persistence, we will not be here today at putting the whole team together. So thank you, Leighton. As you can see, our Burkina Faso, we have our the leader, Dr. Vinsoun Millogo, and from respective universities out there. We're from Senegal. We are a great friend, Dr. Aliou Faye, is providing wonderful leadership and putting several organizations out there. From Bangladesh, we have Dr. Monjurul Alam is our leader, and Dr. Sayan Saha is a co-leader assisting the team down there. We have several organizations as well as the private companies like ACI and Metal out there as well. And Cambodia, we have Dr. Dean Latour Lor and Dr. Dyna Theng. Both of them, they have put together several other organizations like Swiss Contact, SIIL, and CSAIN, many other organizations put together and to achieve our goal. We like to mention that at ASMC Phase 1, we had Ethiopia as one of our active partners instead of Senegal. So for ASMC Phase 2, although we do not have Ethiopia as a very active partners with current funding level, but we are still very much with them. We are still very much working and providing any type of consulting, any type of resources, human knowledge type of thing. So we are still part of it. So we put them in a green color out there. So here are our consortium partners within the US. Again, thank you so much. Dr. Niroj from North Carolina A&T, Dr. Manny Reyes from Kansas State University is also part of the SIIL, and as well as he extensively is engaged with Cambodian and many other partners in that part of the world. Michigan State University, Professor Ajit Srivastava is providing that leadership, and he also has other team members out there, Dr. Harrigan, Dr. Joshi, and Dr. Ranjani, and a wonderful team that are the members are assisting our work. And at University of Illinois, we have Dr. Alan Hansen, whose name should be very familiar to many of you. He was the leader of the ASMC Phase 1, but then he wanted to enjoy his life and put the burden on us. So now he's, I think, participating from England out there. Dr. George Czapar, my great friend, also crop scientist as well as extension specialist, helping us. Miss Maria Jones, we have a wonderful gender specialist, basically an engineering background, but the management degrees and all out there. So Maria is very well connected all over the world with gender issues and many other issues. Dr. Alex Winter-Nelson and Dr. Hope Mickelson, they are both economists, and both Maria and Dr. Alex Winter-Nelson are also connected to this project through the ADM Institute for Prevention of Post-Harvest Losses with funding. So thank you for this group. Last but not least, I would like to thank our science committee members, Professor Gajendra Singh. He has been chairing this the science committee since the beginning of this project. Professor K.C. Ting, his name should not be unfamiliar to many of us, very well-known, world-famous engineer. And he was one of the main persons that actually crafted this ASMC Phase 1 project 5 years ago. Dr. Tofel Ahmed, professor, he's participating from Japan, wonderful young scientist, engineer that has written several books on precision ag and new technologies and things like that. Professor Minli Wang, very famous agricultural mechanization professor from China. And today she just sent an email. She might be actually in a remote location and her connection might not be very strong. So we'll see how that goes. Professor Jeff Smithers, also our new member from South Africa. Thank you so much. And last but not least, Dr. Joseph Kinzel from FAO, who has kindly agreed to give us some direction through this science committee for this project. So thank you so much. I also like to thank all the other members, especially from the other SIIL consortiums. I know Dr. Mandal is here. Dr. Jagadish has some other arrangement, and then few other team members on this project. So with that, our ASMC Phase 2 goal, basically to evaluate and scale transformational technologies for smallholder farmers in both Asia and Africa. We have those 4 countries, or /5 countries, and our goal for Phase 2 project is to reach 5,000 farmers and 5,000 hectares of land. And our emphasis is suitability, scalability, and sustainability. We take the approaches of technology innovations, entrepreneurship, policy, infrastructure, and capacity building. As you hear from our in-country directors and leaders, you will see evidence of all these 4-pillar approach that we are all working together. And of course, the projects will not be sustainable. Projects will not be successful if we don't bring the gender issues out there and women empowerment and engage our youth to be involved in agriculture and food and all those environmental issues in the future. So these are the countries for both Asia and Africa, just to give you all an idea of the whole global picture where we are. In short, some of the technologies that we have in the Phase 1, we have done extensive research on identifying technologies and talk to people about what are the future potentials and things like that. Did extensive research. There are a lot of publications and presentations came on each one of them. And then based on those results and based on those discussions, few technologies that have been selected for scaling up there. These are in Bangladesh: rice transplanter, 2-wheel or 4-wheel tractor-based seed planter, reaper, and combine harvester, and of course the BAU STR dryer, which has made a huge significant impact already in many people, Bangladesh and beyond. In Cambodia, and our groups are working with Swiss Contact and other partners there with the no-till planter, broadcaster, leveler, and cover crop practices. They are showing some examples to the world about the cover crops and sustainabilities and engaging smallholder farmers for vegetable and fruit production and things like that. In Burkina Faso, our friends are working extensively through a lot of challenges and all, still making a lot of progress. Strip till inline reaper, minimum till planter, small scale forage chopper, small scale silage bin, 2-wheel tractor, and solar drip irrigation system. And finally, Senegal, Senegal is our newest country for ASMC. However, Dr. Aliou, he has, arranged a whole group of team members from different organizations. And now our plan is to proceed with planter, manure applicator, composting system, small scale forage chopper, solar drip irrigation system, two-hole electric tractor, small scale grain storage, and possibly also transfer the STR BAU dryer that we have developed for Bangladesh to be transferred into Senegal. So that is our plan. In this phase two, we work in scaling up technologies by two of our experimental methods. One is a gap analysis, another one is a technology readiness assessment. In the gap analysis is systematic analysis of the critical value chain features that are needed for scaling up a technology. This analysis will or already have identified some bottlenecks and opportunities for scaling, and you will hear from Dr. Ranjani, Ananthakrishnan, and Dr. Alan Hansen. Technology readiness assessment. Also, this is an ongoing work. We have already got a lot of data on that. Assess technology's potential for adoption at large, and focusing on technical feasibility. The gender integration, you will hear from Maria. We connected a lot of organizations and other in respective places out there, but our overarching goals are to ensure that the women farmers can assess and benefit from this mechanization and various mechanization practices and resources that we have. Also build capacity among the institutions for designing, disseminating, and enabling adoption and continued use of mechanization among and with women farmers. The youth engagement, Dr. George Czapar is the lead, and also we have another, as Leighton said, we have a guest artist today that will be giving some wonderful information on that. So how are we engaging them with the schools and other local partners? Another one that our leader, Dr. Czapar, has been pushing it, have those our country partners follow something, the principles of 4-H, but design in their own country specific ways. And I'm happy to inform you that, especially and our Bangladesh Agriculture University partners, they have already have a beautiful plan that is already developed, and we have already talked, and I'm sure you will hear about that today. The key achievement there are, you will hear from what achievements have been made through phase one. One thing that I will not be fair if I don't mention, for Bangladesh project, we have made a policy change. So they have a wonderful conference workshop very recently, and for last few years, after they have demonstrated the use of the combined harvester and transplanter, how it saves money, how it improves yield, how it remove the labor shortage challenge that they have. So the Bangladesh government, they have made a law that they are going to provide 50% subsidy to for combined harvester and other significant machines, but also in some other areas, some very challenging areas, and especially the areas where we have, I think, our polder area, another SIIL consortium, about close to 70% subsidy to for farmers to buy combined harvester. And there's a picture, as you see, on a daily basis, we are updated with the website or the Facebook about the farmers. They are getting their combined harvester. So that's a kind of a revolution happening there. The farmers are getting out there. We have developed a website, and I hope our members, they all know that. and at Illinois, we've taken that initiative, but this belongs to all of us. This belongs to the people. This belongs to farmers. This belongs to the whole humankind. You know, we want to put all the information from this project and beyond into the website. So I think Dr. Casey Ting always wants to emphasize, and I work with him many years, he always wants to say a word, one-stop shop. I learned that. And so this is what is our plan, and it's also supported by Dr. Prasad. So we already have completed the website, and now we are putting a lot of information. So please go to the website and look at some of our information. The ongoing work that we are developing a digital database, and this we started, you know, with few selected countries, but our goal is to have many countries in both Asia and Africa and beyond, hopefully getting all the information about technologies, tools, mechanization practices, performance, research, scope, cost, and the life cycle analysis, government support in each and every mechanization tools or practices that we have, and these will be available to all of us through our website. And we have just recruited one of our young graduate, Aditya, as Leighton mentioned, Aditya is working on that. So our goal through this database is to make it available for everybody, and maybe connect that with the decision support tool for people to get some help. If someone else is, for some country within our partner countries and beyond, want to use for certain crops, certain mechanization, looking at the cost and performance, they should be able to take a good help. We just launched a mechanization survey for Africa. It has been designed by our whole group. A lot of people have given input on that. Professor Gajendra Singh, Professor Ajit Srivastava, and our ASMC team here in Illinois, as well as Dr. Vara Prasad and our good friend Jan provided, you know, so much input and assistance. So we launched that on June 1st. Hopefully in 30 days, we will be able to get good information what's happening in terms of agricultural mechanization in Africa. And simultaneously, parallelly, we will be having another one on for Asia very soon. And of course, the TRA and scaling gap analysis data have already been collected, as I said, and people are working, our partners are working with that on. So with that, thank you very much. I hope I didn't take too much time. Maybe I did. I have a bad habit of always exceeding the time. But thank you again. Let's enjoy the day and hear from our friends and encourage us. Anything that you have, please put your questions on the chat room. So thank you so much. Leighton, thank you very much.
Thank you.
Thank you, Dr. Kalita. So for the sake of time, we will move to our next speaker. And Dr. Kalita, if you want to, you can stop sharing your screen now. Oh, no, this is already Vara. Thank you, Vara. You've already started sharing. So our next speaker is Dr. P.V. Vara Prasad. Dr. Prasad is a university distinguished professor, R.O. Cruz Professor of Agriculture, and director of the Feed the Future Innovation Lab for Collaborative Research on Sustainable Intensification at Kansas State University. His research focuses on understanding responses of crops to changing environments and developing best management strategies to improve and protect yields. He is passionate about research, education, and outreach activities, and building human and institutional capacity. He has active programs in several countries in Africa and Asia, focused on improving livelihoods of people and providing food and nutritional security to smallholder farmers.
You gonna go up to the attic?
He is an elected fellow of American Society of Agronomy, Crop Sciences Society of America, and American Association for the Advancement of Science. He currently serves on the International Commission on Sustainable Agriculture Intensification and as the president of Crop Science Society of America. Dr. Prasad, thank you so much for being here today, and you may now proceed with your presentation.
Greetings, everyone. I'm really excited to be participating in this online program, and just listening to Prasanta and learning about the people you brought in to this consortium is really mind-boggling. I see this consortium as a global leader when it comes to needs for mechanization for the global south and beyond. So I think I foresee that this mechanization consortium will be the thought leader for anybody who is thinking about mechanization in the global south. And I'm sure that you will be developing a one-stop shop, which will not only provide to the audiences, whether it is researchers, policymakers, practitioners, or extension specialists or private sector, to know what is the ecosystem of mechanization in the global south, and what are the gaps, and what are the needs, and how your consortium is specifically addressing those needs. And also, hopefully, there'll be a nice database of existing designs of mechanizations, and then also what are some of the specific changes that are needed to be adopted to the local regions of those countries, and a database of the technologies, so that anybody who thinks about mechanization, you guys are the first people who come to their minds. So with that, I know that you're in a very good hands of a leadership from Prasanta Kalita and Alan Hansen, and several directors and the science committee, and the leadership of Jayendra Singh. I'm really looking forward to working with all of you. I'm sure you have developed a nice program for today to learn about this mechanization consortium. But in the next 12 or 13 minutes, what I'm going to do is give you an overview of our Sustainable Intensification Innovation Lab. One of the components of that is mechanization. The idea here is to get you all a feel for how we can really address the needs of the farmers and address food security, malnutrition, and climate change, so that you have expertise in beyond mechanization to ensure that your technologies are reaching the farmers. I'm really excited to see the first when all of you turned on the videos. There are lots of familiar faces and from a lot of places around the world. So thank you for doing this. So I'll be covering these 5 topics very quickly. First, I'll talk about the U.S. government's Global Hunger and Food Security Initiative, and then reiterate what sustainable agricultural intensification is and why do we need sustainable agricultural intensification, and then provide you a portfolio and summary of the Sustainable Intensification Innovation Lab. And I'll end up by just giving you a few slides about the current status of investments in innovation in agriculture in total in Global South, and sustainable ag intensification, how much of that is going to sustainable ag intensification, and who is investing in mechanization and how much, so that you get a perspective of the globe. Total R&D, how much in sustainable ag intensification, and how much of that is going into mechanization. Hopefully that will be a trigger point for us to move forward. So about the Feed the Future program, it is a whole of the government, US government Global Hunger and Food Security Initiative, started in 2010, and then converted into a Global Food Security Act, signed into law in 2016 with a bipartisan support. And it was reauthorized in 2018 with Global Food Security Reauthorization Act for additional years. And it's a whole of government initiative. It brings 11 US agencies which are listed there, but USAID is the lead agencies. And the primary goal here is to develop host country-led priorities with the aim for journey for self-reliance. And it includes all major components, research, capacity building, and developmental activities. And initially, when this program was started, there were several Feed the Future countries, about 19 of them, which are spread across Africa, Asia, Latin America, and Caribbean. In 2017, those numbers were decreased to 12 total, based on the target investment and where the impact could be. In Asia, there are Bangladesh and Cambodia. In Africa, it's Ethiopia, Kenya, Uganda, Ghana, Mali, Niger, Senegal, and Nigeria. In Latin America, it is Guatemala and Honduras. And then this program is currently being revised And there were some additional resilience countries or alliance countries which are added. And they're also in the process of developing their new research strategies, which will start in 2022. So there's a lot of excitement and new opportunities coming into play. First of all, what is sustainable agricultural intensification? The idea here is to increasing production and access to safe and nutritious food from existing farmland while minimizing negative impacts of environment and natural resources. That's a goal. The idea is to optimize the production of farming system per unit area, per unit time, with emphasizing on redesigning efficiency and diversification of our farming system. The combination of terms sustainable and intensification is odd, but it indicates, at least tell us, that the outcomes of more food and improved natural resources can be achieved simultaneously. So that's the goal here. And it requires systems thinking, not only investing in biophysical sciences, but also social sciences for creating enabling conditions and building social capital so that our innovations are scaled and reach out to the farmers and they can implement it at scale so that it can have an impact on food security, malnutrition, and addressing the climate change. And this sustainable ag intensification umbrella covers or includes climate smart agriculture from both adaptation and mitigation perspective, and also the regenerative agriculture, which goes beyond not just minimizing the negative impacts, but actually enhancing the natural resources. So it provides us a nice platform to address the challenges, the global challenges which we have. Why do we need sustainable intensification? Because we have limited availability of arable land, limited water resources, nutrients, energy, and labor. So therefore, we have to use them very efficiently and increase the resource use efficiency. We're also seeing increased land degradation, threat from climate change, and need for improving the food insecurity and addressing the malnutrition, and more importantly, meeting the sustainable development goals in the time by 2030. We're all moving very slow in that direction, but hopefully the new research strategy and UN Global Food Systems Initiative and COP26 will allow us to speed up and reach our goals in time. In the past, we have primarily focused on intensification. Production increase has been coming from bringing more land into agriculture and also increasing the yields by more inputs. And we have favored monocropping, but these led to increased degradation. And those practices were not sustainable. So we saw decreased or slower productivity gains for major grain crops. So we need to reverse this trend. And as I said before, innovation and research, understanding barriers of adoption, and building human capacity through education and extension is important. SI is not a silver bullet, but it takes a holistic approach and provides choices and evaluates the trade-offs and creates enabling environment. And again, emphasis on both biophysical and social sciences with support from institutional building and human resource capacity. So now coming to the Sustainable Intensification Innovation Lab, it is one of the 21 Feed the Future innovation labs we have, and it is one of the largest, and it has a very broad portfolio and takes a systems approach to address the grand challenges of food security, malnutrition, and climate change. And Kansas State University is the management entity for that. Our vision is that SIIL becomes a global leader in interdisciplinary or transdisciplinary research, knowledge sharing, capacity building on sustainable agricultural intensification, and producing measurable impacts on improving farm productivity, income, and nutrition of smallholder farmers. I think that's our vision, and we're already there. If not, our goal is to make sure that we reach that vision in this space. We have multiple areas of inquiries. We have taken a farming systems approach to identify our gaps and fulfill those gaps. And these are the five broad areas which we are currently working on: integrated crop livestock systems, sustainable and efficient use of land, soil, nutrients, and water management systems, looking at climate smart and resilient farming systems, and increasing the biodiversity. So those are the targeted areas in each of our countries which we'll be working. And of course, your consortium is focused on designing, testing, and scaling mechanization tools. We have a Geospatial and Digital Tools Consortium, which is going to develop tools which will be valuable for researchers, policymakers, and decision makers to identify the regions where there are opportunities for sustainable ag intensification, and also look at what options they have and track the goals or track the progress towards sustainable agricultural intensification. We also developed a nice framework called a Sustainable Intensification Assessment Framework, which provides a nice set of domains, indicators, and metrics at multiple scales, starting from plots, farms, and landscapes to determine the impact of sustainable intensification practices. And of course, gender and nutrition and youth are integral part of all of our programming, right from the leadership team all the way to the implementation in terms of partners and also reach to the practitioners as well. And again, as I said, we also are focused on social sciences to understand the barriers of adoption and research and scaling, and then also develop several coordination hubs in some multiple regions to track our investments and partners and their activities which are working on agri-food systems. So we started in 2014 and we will continue up until 2024. And in the initial phase, we had much more countries listed here from 2014 to 2019. In addition to the 5 countries, we were in Ethiopia, Tanzania, and Malawi. But right now we are in Senegal, Bangladesh, Cambodia, Burkina Faso, and Niger. But of course, we always take a regional approach to our research. Whatever we developed in these initial targeted countries, the impact or those technologies can be used for the in the regions, in the broader regions, or in those farming systems. So here's a full portfolio. I know it's very large, so I'll be just naming them and listing the names of the people, and I'm sure our website will provide you more information if you want to go into details. So we have in this phase, we have programs in West Africa, Senegal, Niger, and Burkina Faso, Asia, and Bangladesh, and Cambodia. And they are focused on crop livestock interactions, focusing on dual purpose crops, millet, sorghum, and cowpea in West Africa. And in Asia, we're looking at rice and rice fallows, and commercial home gardens, and then perennial gardens as well. And then in the past in East Africa, we were in Tanzania and Ethiopia, where our focus was on cereals, legumes, and water management. So we have 4 consortiums and 2 initiatives and the country programs. And appropriate scale mechanization is one of the consortiums led by Prasad and your team, and you'll learn a lot about it in this meeting. And the second consortium is the Digital Tools and Geospatial Farming Systems Research Consortium, which in the first phase worked with the University of California, Davis. And then in the second phase, it is being led by Ignacio Simpiri at Kansas State University. But we also have a policy research consortium, which is led by Rutgers universities. And then they look at the policies which have been effective and how to improve the policies moving forward. And we also have a International Fertilizer Development Center's SIIL Consortium, which is led by Upender Singh from IFDC. And then we have 2 initiatives. The first one is called SIIL. I was glad to see Director Buntan here, Center for Excellence on Sustainable Ag Intensification and Nutrition. That is at Royal University of Agriculture in Cambodia, under the leadership of Director Buntan, and Leda Haq is the director. And then we have another initiative called IREACH, which is the Research Education Advisory and Coordination Hub, which is in collaboration with CORAF, led by the DG, Dr. Pencano, supported by Research Director Jolaf, and Lemaine is our coordinator there. So that hopefully gives you a nice perspective of the overall research programming of our labs. And then, as I said, in West Africa, we are focused on crop livestock interaction, dual purpose crop. We have 2 programs there, Senegal and Niger, which is led by Duhan Men from KSU, and Aliou Faye and Isra, who is in this meeting and will present about his mechanization hub. And then in Burkina Faso, where we support a long-term soil fertility management crop rotation led by Hamidou Traore and his team, Mariam and Jibril. In Asia, we are in Bangladesh and Cambodia. And Bangladesh project is led by Krishna Jagadish and Sudhir Yadav. And I'm thankful to the Bangladesh team for collaborating with this team. They're primarily focused in the poorer communities. And in Cambodia, it's led by Dave and is focused on scaling suitable sustainable technologies, primarily focused on horticulture crops, cover crops, and then wild gardens. Thanks for collaborating with that team as well. And we have a small project in looking at impact of bean, led by Myvish Meridia, which is focused on Latin America and Central America, Michigan State. And just to quickly close out, I think the 5-year summary from 2014 to 2019, we have collaborated with 93 different organizations, supported about 120 individuals, 80 national and international centers, 13 US universities, and we trained about 115 students, 67 masters and 48 PhDs, and about 40% of them being women. And we trained close to 13,500 individuals with 268 individual trainings, unique trainings, and again, 40% of them being women, and about more than 500 publications, 54 data sets in open data. Then I'll finish up by just quickly stating about the Commission on Sustainable Ag Intensification, which is led by a CGIAR initiative. And then there are 21 commissioners, and I happen to be one of the commissioners. One of the first things which we did was look at the status of investments in innovation, primarily innovations, not other activities, but innovations in agriculture. And then how much of that innovation is actually spent on sustainable ag intensification in global south. As you can look at it from 2010 to 2019, on an annualized basis, the total investments which are going in to the level of 50 to 70 billion, which may look high, but it's very minuscule compared to the total agricultural output, only 4.5% of it. The majority of that investment comes from the public sector, followed by bilateral or the development partners, followed by private companies. So that's a distribution. And when you look at the total investment in agriculture, how much of that is actually in sustainable agricultural intensification? Considering that 50 to 70% as 100%, only about 3.5 to about 7% is into sustainable ag intensification. So that's less than 5%, which is going into sustainable ag intensification. If you take a stricter term of looking only at environmental, it's 3.5. And if you add social and human condition, it reaches up to 7. So that's very, very, very small amount. And of that, who's investing in mechanization? If you consider the private sector and the venture capitalists, that number was about 10 to 20 billion dollars per year. Of that, 90% of investment is coming from private sector, and only 10% is from the venture capitalists. So that makes 100%. Of that 90% which private sector is investing, about 26% of that is going into farm mechanization. Rest is into pesticides, seed development, meat, and others. So that's very little. Of the funds which private sector is looking, only 25% of that is going into ag mechanization. So these are very small numbers. And this commission has recommended that there is a critical need to increase the level of investment in innovation in general, and also in SAI. And then future investment should focus on components beyond productivity, looking at economics, human condition, environmental, and social. And then more importantly, there has to be a transparent reporting so that we know where the investments are coming, who is investing, and how to redesign our program. And again, with that, I'll end, and thank you for all the principal investigators and team leaders who are listed here, and several of you are participating in this meeting, and also the SIIL team advisors, our external advisory board members, coordinators, affiliates, and KSC leaders. Thank you so much for your support, and if you need any more information, please follow us. And again, our role is to make sure that your project is successful. Tell us your success stories, and then our goal is to disseminate that to the proper audience. Again, thank you so much for giving me the opportunity to talk about SIIL, and looking forward to learning more from this Inception meeting. Thank you.
Thank you very much, Dr. Prasad. We are very thankful that you were able to to share that overview of SIIL with us and that you were with us today. At this time, I will share my screen before our next speaker. I'm honored to introduce our next speaker, President Emeritus Robert Easter. President Easter grew up on a grain and livestock farm in Southwest Texas and earned his undergraduate and master's degree in agriculture at Texas A&M and his doctorate in swine nutrition and production at the University of Illinois in 1976. He then joined the University of Illinois College of Agriculture faculty, where he taught swine production and nutrition courses, directed master's and PhD students in swine nutrition research, served as head of the Animal Sciences Department, Dean of the College of Agriculture, Consumer and Environmental Sciences, interim chancellor of the Urbana campus, and for 3 years prior to his retirement in May 2015, as president of the University of Illinois system. He is a fellow of the American Society of Animal Science and an honorary member of the American Society of American Society of Agricultural and Biological Engineers, and a recipient of the Illinois Farm Bureau Charles Schumann Award and the Friend of Growmark Award. In 2008, President George W. Bush appointed him as chair of the Agricultural Advisory Board of the United States Agency for International Development. He currently serves on the boards of 5 non-governmental organizations and is an advisor to the ADM Institute for the Prevention of Post-Harvest Loss and the Illinois USAID Soybean Innovation Lab, both at the University of Illinois, and the advisory board of the USAID Feed the Future Innovation Lab for the Legumes Project at Michigan State. We are very grateful to President Easter for taking the time to provide today's keynote speech at our ASMC Phase 2 Inception meeting. We are aware that he has another very important engagement for the rest of his day. And since we are already running behind, I will quickly hand it over to him. But we are very thankful that he has joined us to provide valuable insights and wisdom to our group. Thank you, President Easter, for joining us today, and the floor is now yours.
Thank you very much. I very much appreciate the opportunity to be here. My interest in international engagement and activities such as this one has obviously been going on for a long time, and it's a privilege to be here. Prasad asked me to comment on a study that was done by the National Academies back in 2018, reported in 2019, basically to give some insights on directions that agriculture research in the United States might be going. Obviously, these ultimately become decisions that are made at different levels, but this, I think, is an important study. I should have control, and let's see if I'm moving here. I'm not, Leighton. I wonder what's happening. There we go. I want to just, and I'll try to move through this very quickly. I do have some later appointment, but I have some time here, so I'm not under real constraint. I want to say just a bit about how agriculture funding developed in the United States. Back in the 150 years ago, the country had several pressing needs. It was beginning to develop industrially, and as factories began to develop in cities and industry began to develop, there was a critical need for increased efficiency of food production, how to feed additional people who weren't living, if you will, hand to mouth on the farm. And we were in the midst of the Civil War, so there was also a need for military leaders. The Land-Grant Act was passed in 1862, and the system of which University of Illinois and a number of the other institutions represented here are members was created by federal funding. There was a need for research support to support agriculture research. And so the Congress in 1887 passed the Hatch Act, which basically said, states, if you will build an agriculture experiment station and fund faculty to work in that station, the federal government will provide matching funds by formula based on population of the state and agriculture productivity. So this became the primary mechanism by which agriculture research was funded in this country, by formula. It was designed to address local needs in individual states, obviously. And it was the first model actually that our government had for federal government involvement in supporting research generally, but agriculture specifically. At the end of the Second World War, there was a detailed study of how research should be supported going forward. It was done by an individual by the name of Bush, and it was no relationship to the former president. And it was reported out. And it made a comment that I think is fundamental and one that you would understand. New products, new processes don't appear full grown. They're founded on new concepts, fundamental principles that are discovered. And then those are translated, as you are doing, into application from their discovery and, if you will, fundamental science. And the decision was made at the national level that universities would be the primary national infrastructure, and they were focused at that time on the Soviet Union, but the primary national infrastructure. There would not be a great number of national labs established, but rather research would be funded within universities. And the notion was that universities would primarily focus on basic research, which would be translated into products and application by industry. The consequence of that was the passage in 1950 of the creation of the National Science Foundation, and its purpose was to fund research, and its priorities were established by a National Science Board. Grants were awarded competitively, as many of you are aware. Health became a greater interest in the 1960s, and as a result of that, the National Institutes for Health were created, and funding was created for the NIH, which today is a major source of funding for a lot of university research. And then in the 1980s, the Congress looked at all of this research being done at universities and said, somehow we need to increase the movement of that into application. And so there was a whole series of acts passed by Congress that allowed universities to patent technology and then to profit from its transfer, if you will, into product and into application. So the question today, as we think about the future, begins with, is the government today, the federal government, providing sufficient funds for food and agriculture research? And is there justification for assigning greater emphasis to food and agriculture research? I don't think that's a question for those of you participating in this event here today, because you fully appreciate globally, domestically as well, the need to increase the efficiency, the productivity of our food as we grow populations, as we increase movement of people from rural areas into urban areas. There's a whole host of questions that need to be addressed. And from our perspective, at least from my perspective, having engaged significantly internationally, there is a very real need to give greater attention to food and agriculture research. Well, who's paying for it today in the United States? Well, all R&D in agriculture is about $3.3 billion. And roughly half of that is coming from the private sector. There's quite a lot coming from the private sector. The federal government is putting in about a billion. State and local governments are putting in less than that. Institutional funds, that is the dollars that support faculty and so forth, facilities on campuses are also coming in. This is research that's being done primarily within the universities. How much of the federal support for academic research, university research, is actually going to agriculture? Well, as I mentioned, Health and Human Services, National Institutes of Health, about 55% of what universities receive, at least in these data, which are sometimes difficult to come by, 55% in 2012, 2.6% to support agriculture research. NSF is at 13, Department of Defense at 12. So I think just off the surface, one would say that's not giving agriculture research a very high priority, unfortunately. Within USDA, where those dollars are allocated primarily to support agriculture research, you can see the different places that it goes. The USDA's own internal research system gets about 1.6 billion. And these are 2020 data, so it's more recent. The part that goes to universities comes out to be a 1.5, so roughly an equal split between the internal USDA science apparatus, and that which goes to universities. You can see a number of the programs. Competitive grants continues to be an area of emphasis. The formula funds, which began in 1887, continue to go on, but of diminishing quantity, and not quantity, but not increasing at the rate at which formula funds or competitive grants are increasing. Many voices have looked at these numbers and said there needs to be more funding allocated for agricultural research. And I've listed a number of the organizations that represent universities, represent professional societies, the commodity organizations, and many others. And when they go to members of the Congress and say, you need to increase funding for agricultural research, there's not much success. And the question that comes is, why not? And the challenge has been determining priorities, because when they go to the Congress, these representatives, and say, we need more money for agricultural research, the congressional response is, well, what do you want to do? If we listen to this organization, it wants research for these dollars, for this program, somebody else research for this, somebody else for this. We're confused. You can't tell us what our priorities should be, where we should put the money. Two organizations looked at this about 4 years ago, and I happen to be part of the first organization. They're supporters of agricultural research. I sit on their board. These two organizations, the Foundation for Food and Agriculture Research, which is a major funder in Washington, and Supporters of Agriculture Research, put about $600,000 on the table and went to the National Academy of Sciences and said, would you be willing to take on board an independent study to look at what priorities should be in agricultural research? And so this document was produced as a result of that, focused on 2030. What should we be doing to achieve what needs to be done in terms of meeting the global demand for food by 2030? You may be familiar with the National Academy process. It operates completely independent of the funders. In other words, you basically write a blank check, and then the Academy goes about setting up a committee of experts to address the issue, and their own internal staff support that. And at the end, the product is delivered to the funders. And I'll not go into the listing here, but it was an eminent group of scientists, individuals working across the board in food and agricultural system, co-chaired by a couple of individuals that are listed here. Those of you in agriculture and biological engineering will recognize immediately the name of Norm Scott, who's at Cornell, a very senior individual, national member of the National Academy. Norm was one of the reviewers who oversaw this as it came into its fruition. So what was the result of this conversation? And so I want to just quickly talk about, they saw, and I don't think you'd disagree with these, three major goals: improve the efficiency of the current system that we have, and increase the sustainability of agriculture, which this broader project is involved very much in, and increase the resiliency of agricultural systems to change. And obviously climate change underlies this, but there are a lot of other changes taking place as agriculture faces different challenges around the world that come upon us very, very quickly. And you can just think of some of the disease issues that are affecting certain crops that emphasize that point. What are the key research challenges that they identified? Well, nutrient use and the efficiency of nutrient use in crop production systems. Basically, how do you more effectively provide the nutrients, the fertility that crops need to produce optimally? Worldwide, I think we deal with issues of soil loss and degradation. How do we continue to optimize the genetic diversity for sustainability of crops, but also to more appropriately address very local needs that may be different in terms of the crop production in different parts of the world? Obviously, water is a major concern as we continue to go farther, particularly with climate change. Food animals, genetics of animals that increase not only their health and well-being, but give the focus on their productivity and the efficiency with which crop products are consumed by the animals and converted into nutrients that humans can use. How to make these systems more precise using technology, early detection, prevention of disease, and also detection of foodborne pathogens that we humans are concerned about. And as was alluded to earlier in the comment about the ADM Institute for the Prevention of Post-Harvest Loss, how do we actually reduce the amount of food that's lost between the point of harvest and the point of consumption? It continues to be an embarrassment, I think, to most of us in our business, in our field, that those losses, particularly in parts of the world that are under-resourced, are considerable. And there's also not just the loss, but in the more affluent parts of the world, the amount of food that's actually delivered to the end consumer, but in the process, not utilized as a source of food. Well, and this was alluded to in the director's comments. Just a minute here. We're back in business, hopefully. Okay, the director's comments about the need to have an interdisciplinary approach to dealing with problems. It's a challenge for us, but as science has advanced, we've become more and more reductionist. We've focused more and more in depth on a particular area and not really engaged broadly with other disciplines, with other areas of research. And so the challenge is, particularly as you think about these problems that are trying to be addressed, that we need to address, how do you actually increase the integration and the use of interdisciplinary, not just across the sciences, but also across the basic sciences, but also across human study, human science, human behavior, et cetera, to optimize success? How do you be more holistic as you approach a problem and look at it from the whole, rather than just separating out into individual disconnected parts? Multidisciplinary solutions are critical. It's an issue of convergence. As you approach the problem, I'm delighted to hear what we heard just a few minutes ago about the need to go across disciplinary boundaries, integrate knowledge, bring tools from a variety of different areas of work together to address the problem. The report talks about moonshots, and maybe this is something that I need to say just a word about. Back in 1962, our president at the time, John Kennedy, said, "We're going to the moon." And most of the world's people kind of laughed and said, that's kind of ambitious. And the reality is that creating the goal, creating the moonshot, creating the goal actually enabled the momentum to develop, the innovation to occur, the discovery science to occur that actually made that possible. So as you think about moving forward in the food and agricultural system, what are the moonshots? What are the things that may today seem to be impossible, that if given focus, given attention, and given human ingenuity, can actually be achieved? And so here are some of the breakthroughs that I want to focus on as we bring this to closure, that are viewed as goals that need to be achieved. And a breakthrough is where you understand a system and you manage to leverage the tools that are available broadly to achieve a desired goal. And the recommendation of the report was that these transdisciplinary science and systems should be prioritized. So saying to the legislators, it's not just focusing in engineering, it's not just focusing in biology, it's not just focusing in another area of discovery, health, for example. It's integrating all of these into a systems approach where funding needs to be provided. So breakthrough, the notion of sensors field deployable sensors that would enable rapid detection and monitoring of capabilities across the food and agriculture disciplines. And again, suggesting this National Academy Committee suggesting that this be an area of focus, and that the recommendation was to provide funding to create an initiative to more efficiently deploy existing sensors technologies and develop new sensing technologies. And if you're familiar with the work going on in the area, it's absolutely amazing what is being accomplished. The second is data management and how to optimize data broadly defined, from climate data, weather data, soil data, fertility data, all the other data that you need to efficiently and effectively increase food production. How do you incorporate all of that and bring it together in order to achieve some real progress, moonshots in a sense? And that's discussed here in the recommendation for funding. The fourth breakthrough, the ability to carry gene editing, and I know this is controversial, but it's allowed improvement in productivity and safely, I would add. And how do you do that more effectively, more efficiently, and in the process improve the quality of food products that we produce for humans? And so another recommendation was to establish an initiative in the area of genomics and giving greater attention to that. Fifth breakthrough, understand the relevance of the microbiome, what goes on within our bodies, within the bodies of the animals that we grow, but also what's taking place in soils and an environment that influences in a positive or negative way the productivity of crops, the productivity of food animals, and our own, the animals and the crops' resistance to stress and disease. And again, the focus would be to establish an initiative in this area as going forward. Recommended research directions. Well, the focus, obviously, crops, animals, but also food science, soils, water use efficiency and productivity, focus on data science, but above all, an emphasis on a systems approach to solving this. And quite honestly, as I think about this list of 7, it seems to me that the greatest challenge is actually how to build the systems approach, how to integrate concepts developing and new knowledge emerging out of different areas into solutions. That's a significant challenge. I just would use an example from my own background. Research directions in animal agriculture, better disease, management of using data, improvement in traits in livestock and poultry, and also aquaculture, an increasingly significant source of the world's food supply. How do you measure the welfare of an animal, the health of an animal? Obviously, it's connected to not only our concerns about the animal, but also the productivity. And how do you manage to create sustainability within agricultural systems that involve livestock? They also commented about not just funding the research, but further considerations. And there's a major initiative in this country, at least ongoing in Washington today, to provide new funding for the tools, the equipment, facilities, and the human capital. If you visit most universities doing agricultural research today, I think you'll be depressed in some sense by the extent to which the research environment is hampered by the lack of modern or state-of-the-art tools, analytical machines to the from analytical machines in the laboratory across to the field technologies or field application of technology. They also, at least for this country, talked about continue to support the agricultural experiment station as a network and also the extension system. Take it to the farmer and test it before you do as a way to increase food production. They make the point again, which has been made throughout the report, that current and public-private funding for food and ag research is inadequate. And there's a need to, at least in the US, to bring a next generation into agricultural research, and not only research, but the actual management and production, the actually doing of agriculture and food production, and the logistical system that delivers processing it to the ultimate consumer. How do you get the next generation excited about food and agriculture? And how do you build a greater link between biophysical systems and the socioeconomic understanding of how individuals respond within those systems? There's something missing. And I think one of the things as I've looked at this report is the lack of emphasis on the reality that smallholder farmers, the individuals that you're focused on in this project, amount for a significant portion of the world's food production, particularly in resource-limited countries. Some studies suggest it may be as high as 70%. The one that I've cited here talks about 30 to 40% of the world's people are provided their food, or the world's food is provided to people by these smallholder systems. As we think about the science and the work that can be done at the fundamental level, how do you take advantage of that as you focus on the objectives of this project? And I think that this is a group that has the opportunity to do that and has the capacity to do those things. Challenge is to how do you bring discoveries that will be the result of the work that's envisioned by this National Academy report. And in the particular case of today's conversation on mechanization problems focused by smallholders. And there's the reference to the article there. And with that, I'll draw this to a close.
Thank you so much, President Easter. We're extremely grateful for your willingness to share your insight and to also be with us today. As mentioned before, we know that you have another important engagement for the rest of your day. However, we welcome you to stay as long as you're able. But thank you again for your wise words and best wishes. With that, we will now transition to hear from our ASMC regional coordinators, country project leaders, and their respective teams. First, we will hear from our Asia Regional Coordinator, Dr. Manny Reyes. Dr. Reyes, a research professor at Kansas State University, has more than 30 years of experience working with water quality modeling, natural resources management, and conservation agriculture. He is an agroecological engineer designing food production systems that mimic nature. Reyes has extensive expertise across the globe in research, extension, teaching, and project implementation. He has served as the Cambodia country coordinator for the ASMC Phase 1 project. In Phase 2, Dr. Reyes coordinates profitable engagement of the private sector to rapidly spread appropriate conservation agricultural machinery and tools which will change the Cambodian countryside. He also facilitates partnerships with other Feed the Future innovation labs, international organizations, and private industry in Cambodia. Thank you, Dr. Reyes, for being here, and the floor is now yours.
Thanks so much, Leighton, for the introduction. Quite excited to relate to you. I'll be acknowledging several people in these slides. I couldn't read their names, but you know who you are. This is an Asia overview. But let me invite everyone to the 3rd International Sustainable Agriculture Intensification Nutrition Conference to be held in Siem Reap, Cambodia, 10 to 11, January 2022. We're quite optimistic that by then, likely we can travel to the beautiful Kingdom of Wonder. the country of Cambodia. There's a call for abstract, and I could share in the chat later on the link for the call for abstract. But I hope that you could all engage with me, and to whet your appetite, I'll show the picture of me and my wife. This is the Angkor Wat temples, and also my son. I love Angkor Wat so much. I brought my son when he was 11 years old, 12 years old, 13 years old, 14 years old, and 15 years old to the temples of Angkor Wat. So please join us in the conference in Siem Reap, Cambodia, and enjoy the beautiful Angkor Wat temples. With that, that's my son too. But on the overview, the length in Asia is the strength of Bangladesh on appropriate harvesting machinery, and the strength of Cambodia on conservation agriculture machinery. And due to COVID-19, I was unable to travel to Bangladesh. I've not traveled to your country, Dr. Alam. I wish I was able to, but we all got into this COVID-19 angle. But I will emphasize, so in that case, I will emphasize on my engagement in Cambodia for 11 years. Focus is Cambodian conservation agricultural machinery, and my colleagues in Bangladesh and also in Cambodia as well, they will emphasize the machines that they have done, but my colleagues in Bangladesh will relay her strength on machines for harvesting. So with this case, if you look at this, this is the depleted, very sick soil in Cambodia, and take note how beautiful the soil became, the healthy soil because of conservation agriculture. Quickly in pictures, conservation agriculture, this is all in Cambodia, no tillage. There's permanent organic soil cover, and there's the diversification of species, all biological mimicry of what's happening in the forest. And Cambodia, I would relay, is the leader in conservation, on conservation agriculture in Southeast Asia. Let me repeat that 3 times. Cambodia, we're very proud to say, is the leader on conservation agriculture in Southeast Asian countries. Cambodia is the leader, to cease to believe. Pictures are all in Cambodia. Cambodia is the longest 15 years conservation agriculture experiment under no tillage of this size in Southeast Asia. The Ministry of Agriculture, Forestry and Fisheries dedicated 14 hectares of land for conservation, for the Conservation Agriculture Service Center headquarters. And this Cambodia is generally centrally located in the Southeast Asia region. So we're very proud in Cambodia. We are linked with several international organizations, USAID, the AFD through CIRAD, Swiss Contact, and of course the Royal University of Agriculture, which is very, very essential and important, knowing our mission of education, research and extension, and the General Directorate of Agriculture, which is in the Ministry of Agriculture. Take note, the Technology Park of Boknor, 15 hectares. This is what I was relaying. And the other one is we've had early maize by cassava. We have a lot of production systems right now. Take note the beautiful growth of the crops, and take note the beautiful mulch that was grown in the area. And this is happening in Southeast Asia. We're building carbon, soil organic carbon in this region of the world. We're monitoring the buildup of soil organic carbon. So this is clearly a climate mitigation technology way, which is a preparation for COPs in Scotland that's to be held, wherein we'll have a climate mitigation technology in Southeast Asia. We will have a climate resilient technology because we're monitoring drought resilience, flood resilience because of conservation agriculture. And we also have a productivity technology, meaning we are increasing production because of conservation agriculture. And we have data both for grains and vegetable production. Quickly, it has the longest 11-year study on lowland rice in Cambodia in Southeast Asia. And this is an example of our lowland rice study. Take note, in October, we broadcast we drilled the cover crop. This is under no-till. Just take note, around April, around that region, see how dry it is. See how dry that region is. This is fenced area. We need to fence it because the cows can go in. This is our cover crop in Cambodia of Stylo and Centrosima, producing 20 tons of per hectare of fresh organic matter. This is in the lowland area, and we're building organic matter. We're sequestering carbon in these areas. Just imagine the Cambodia countryside. This will grow in the Cambodia countryside. What a good climate mitigation technology we will develop in Cambodia and the region of Southeast Asia. And just quickly as an example, note, we've developed this technology in Cambodia. We crimped the corn or the cover crop. See that cedar, the no-till cedar at the back. So we crimp and directly put the no-till cedar. Done. In my Filipino language, tapos, the end. We've already seeded the corn. This is under no-till. Wherein look at the savings in energy that this generates. That's why this appropriate scale mechanization consortium is essential in Cambodia and also in Southeast Asia. Take note, the sowing of maize on green cover of sorghum plus Crotalaria juncea and cowpea at 0 herbicide. This is corn at 0 herbicide, sowing maize on green cover of sorghum plus juncea. This is what I just see. So high flexibility of sowing anytime in rolling. Take note, we immediately sowed, and take note, rolling first. So this is what I'm illustrating. We could do this already in no-till. We have the technology in Cambodia, and we are determined to expand this in Southeast Asia. As you relayed, President Easter, the moonshot angle, we have a vision, a goal in Cambodia. We have a vision that Cambodia will be the center of conservation agriculture, propagating this technology in Southeast Asia. Take note the corn, how beautiful the corn is in no-till technology. And just like what happened to Brazil, it all started in Parana, and then it started expanding. This is farmer-driven and also private sector-driven. Today, 25 million hectares, actually more in Brazil. The same thing we're envisioning, our goal in Southeast Asia. Starts in Cambodia and then expands all over the region of Southeast Asia. Essential is that in the success is appropriate scale agricultural machines. What is next? Cambodia is engaging with the private sectors. Thanks to Swiss Contact. Swiss Contact has been relaying the research results we have right now, such as a manufacturer is already importing no-till machines. And then that manufacturer, meaning not manufacturer, but that importer of agricultural machinery is selling these machines. So the project is no longer investing on the buying of the no-till machinery. The importer, a private importer, entrepreneur in Cambodia is importing it, and at the same time right now selling it to conservation agriculture service providers. And those service providers right now is providing this service to farmers, and farmers are paying them. And we're envisioning that this is a circular technology wherein it will just go up because the private sector will move conservation agriculture in Cambodia and eventually in Southeast Asia. I'm so thankful with my Cambodian colleagues who are here, His Excellency Rector Buntan, and all Dean Litter and all our Cambodian colleagues, Rajiv and everyone, because we're all determined to make this happen, including our French partner Sirad on this angle. Purchasing conservation material, agricultural machinery to provide no-till seed drilling. There's the broadcaster, this is through the ASMC technology. There's the seed and fertilizer broadcaster. This one is a motorcycle. We have a crimper. So this is our versatile no-till planter. So we're trying to find appropriate scale machines. At the same time, we have tools for vegetable production, no-till tools. And I'm not showing it in this slide, but we're targeting both the households on no-till tools. These are manual tools, and also machines for grain production. But in the same time, for vegetable production, we also have no-till machinery for vegetable production. Take note, I will end this quickly. Another aspect that is very essential in Cambodia is we have what we call the Cambodia or Open Systems Agricultural Machinery Manufacturer. His Excellency Rector Buntan, Dean Litter, and Dr. Dyna, you recall that Dr. K.C. Theng visited you all through the ASMC link with CSAIN collaboration in January of 2020, pre-COVID. And you would recall that the Faculty of Agricultural Engineering of Royal University of Agriculture is soon to change its name to Faculty of Agricultural Biosystems Engineering. And one of the focus of the Agricultural Biosystems Engineering is Open Systems Agricultural Machinery Manufacturing, wherein students of RUA will have an Open Systems Agricultural Machinery initiative, and it's soon to be led by soon-to-be Dr. Lihor Hin, who will lead this effort, who's in the picture. He will be the department chair of your agricultural machinery systems in Royal University of Agriculture. Take note, soon-to-be Dr. Lihor Hin is instructing one of his students, and this is what you call the Ogun tractor. And remember, Ajit and the rest, you connected me with Horace Clements and also Dr. Hansen. We're moving forward on this. Take note, the Ogun tractor is an open systems machine, and this is the crimper right now. And if you would look at this, this is the crimper developed by the United States Department of Agriculture National Soil Dynamics Laboratory. And this is the no-till vegetable transplanter of the United States Department of Agriculture National Soil Dynamics Lab, Kornecki Kitchler, no-till vegetable transplanter. And they will conduct a workshop in Cambodia in January 2022, because this is an open systems machine. In a sense, this will all our vision is to manufacture this in Cambodia, to manufacture the tractor in Cambodia. This tractor are all hydraulic systems. The design is in the US, but it is open systems. It's shared in Cambodia. And take note, I will end this talk in here. Note how excited the students are. This is in Cambodia to manufacture the tractor, the Ogun tractor, which they will name the Aklik tractor in Cambodia. They did this in 6 hours. This could be done in Cambodia. We are like shooting the moon. We will shoot the moon, President, and we will attain this angle that there will be a made in Cambodia tractor, hopefully by 2022. With that, thank you so much. Leighton, I'll give it back to you. Thank you.
Thank you, Manny. At this time, I will now share our presentations from our Cambodia partners. You will hear from Dr. Dyna Theng, who will be presenting on their work in Cambodia. After his presentation, we will have a brief question and answer period. Due to time, we may only take a couple questions. So please, if you have questions during the presentation, use the chat feature to place your questions. And if you have any questions for what Dr. Reyes has just presented on, you may also use the chat feature there. But at this time, I will share Dr. Theng's presentation.
Good morning, good afternoon, and good evening, all participants. I would like to present you the plan and achievement of appropriate scale mechanization consortium for sustainable intensification, ASMC Cambodia. The content of my presentation include 1. Introduction of current project, 2. In-country project members and role, 3. Impact of key activity in phase 1, 4. Activity in phase 2 thus far, 5. Biggest challenge for current implementation, 6. Plans to overcome this challenge, 7. Plan to collaborate and or technical assistance that is needed, and 8. Gender activity plan. ASMC phase 2 is a 3-year project starting from July 2020 to June 2023. The project expects to reach 2,500 hectares through the usage of 4 technologies include cover crop, seed broadcaster, no-till planter, and land leveler. This phase 2 is implementing by 3 partners include 1. Royal University of Agriculture, 2. Conservation Agriculture Service Center, Department of Agricultural Land Resource Management, General Directorate of Agriculture, and Swiss Contact Cambodia. To reach the target and goal, the project engaged and established partnership with 3 private sector to intervene and promote the 4 technologies. 1. With Smart Agro to intervene on cover crop. ASMC and Smart Agro cooperate to promote the use of cover crop to farmer and stakeholder and develop branding and promotional material for the cover crop. 2. With Larano manufacturer and importer to intervene on 2 technologies such as no-till planter, in which a local made product and or the import from Brazil, and another product is land leveler, the local made one. And the 3rd private sector is Nguyen workshop to intervene on seed broadcaster. The seed broadcaster is the local product and manufactured by this workshop. The ASMC Phase 2 integrate the use of cover crop using seed broadcaster, promote the sale of seed broadcasters to small-scale farmer, large-scale, and service provider, and develop branding of this tool, as well as set up operation and financial system for the better management of the workshop. The project is implementing into province of Cambodia, in Battambang, located in the northwest part of Cambodia, and in Kampong Thom, located in the center of Cambodia. These people are the in-country team members with the role in project management team, supporting team, trainer, and trainees. From phase 1, the project achievements are engaging stakeholders and assessing country-specific challenge, opportunity, and priority. The project established a hub advisory committee. The hub advisory committee members come from government, civil society, private sector of agricultural mechanization relating business, research institution in national and international. The Hub Advisory Committee is a good platform to share knowledge, experience, and to guide direction to the ASMC on agricultural mechanization required by farmers and stakeholders. A strategic plan of agricultural mechanization in Cambodia from 2016 to 2020 was developed and published in Cambodian and English language. The strategic plan was delivered to the project partners, to Ministry of Agriculture, Forestry and Fishery for documentation and for further research and business on this kind of product as it is available in Cambodia. The phase 1 also conducted assessment and identified the existing use of agricultural machinery and equipment. After the assessment study, the phase 1 tested, modified, and promoted a diversity of implements include seed planter, bucket scraper for laser land leveling, seed broadcaster, roller crimper, and vegetable production hand tool. To implement the country-specific activity with emphasis on suitability, scalability, and sustainability. In this line, the phase 1 also promoted conservation agriculture cropping system to small-scale farmers to grow crop on green and dry cover crop, and identify mechanism to engage local service provider into conservation agriculture transition. Accompanying with the modified and developed prototypes, the ASMC Phase 1 produced leaflet, operational manual, and technical drawing and fabrication for local manufacturer to produce and commercialize the prototype, and also for the user as a basic utilization instruction for a correct use, maintenance, and service. The ASMC Phase 1 provided support to develop curriculum for the Faculty of Agricultural Engineering of the Royal University of Agriculture through consultation workshop among steering committee and lecturer of the faculty with participation of international advisor from University of Illinois at Urbana-Champaign and Dr. Manny Reyes. After the consultation meeting, the faculty was recommended to rename to be Faculty of Agricultural Biosystem Engineering, and a 5-year strategic plan and program plan was established in 2020. Regarding capacity building and youth engagement, the ASMC Phase 1 provided support to the study tour of student and faculty members to field visit and learn with the real practicing in the target project area. The ASMC Phase 1 also provided support to the practical training over the classroom theory for the subject of agricultural machinery, material science, mechanic workshop, in the faculty campus and in the workshop. Last but not least is the improvement student practical experience through internship and research with private sector, service provider, and other research group. The activity were recognized as very important by the student and faculty. Last but not least, hand tools for improvement of conservation agriculture commercial vegetable home garden production system was researched, identified, and developed under the support of ASMC Phase 1 as well. A women farmer network was also established in Banan district of Battambang that is a platform to share knowledge, experience, and product sale of vegetable crop. ASMC Phase 2 activity thus far, we recruited 3 trainees for conservation agriculture sustainable intensification with oriented training and joined the internship with Conservation Agriculture Service Center team in Ratanamandal district of Battambang province. A partnership agreement to identify clear roles of each local project partner is developed. Partnership agreement with 3 private sector such as Smart Agro, Larano, and Nguyen Workshop are established. The project field staff in Battambang provide field showcase of conservation agriculture practice as a step in Medcasikor model to small-scale farmers and service providers. Thus far, approximately 50 hectares of land cultivated under conservation agriculture was recorded. The farmer planted maize, mung bean, and pasture crop on this land, and provide supporting document for agricultural mechanization database development. The biggest challenge for current implementation are COVID-19 pandemic and the budget disbursement. The influence of COVID-19 pandemic, the country was locked down in a period of time. A restriction of travel from place to place as well as physical meetings was banned to stay safe of the people. In the case of budget, the lack of budget to implement as the sub-award was made on a cost-reimbursable payment basis. To overcome this challenge, we keep effort to do at appropriate time with possibility, request for some budget advancement. A project of Swiss contact named Innovation Sustainable Agriculture ISA contribute its financial resource field consultants are carrying door-to-door visits to promote the technology rather than big gathering. For their plan to collaborate and or technical assistance that is needed, the ASMC Phase 2 plan to collaborate with Mechanization model to use the model to engage small-scale farmer and service provider. The ASMC Phase 2 will also collaborate with Czapar project and Conservation Agriculture Service Center to provide training on CASI to the 3 trainees from Faculty of Agricultural Biosystem Engineering. For gender and youth engagement specialist capacity building, the ASMC is collaborating with SIIL. The ASMC is also collaborating with SRI Innovation Hub to introduce Ogon tractor or acrylic tractor to high school students. For the gender activity plan, the ASMC Phase 2 is engaging women in farming household in conservation agriculture cropping system practice, reaching women service provider, and capacity building for Faculty of Agricultural Biosystem Engineering agronomists. The expecting output of engaging women in farming household conservation agriculture cropping system practice are to understand the decision-making process in the household for existing early adopter of CASI, assess women's current understanding of conservation agriculture, its benefit and practice, implement suitable training for women in the target household for conservation agriculture, measure the impact of engaging women, and ensure that existing training reach both men and women farmers. For reaching women service provider, we plan to reach them and co-develop gender integration within the existing metaclasical training modules. Last but not least, the gender activity plan to build capacity of agronomists from Faculty of Agricultural Biosystem Engineering, develop a set of simple strategy and tips, provide ongoing technical assistance, and collect disaggregated data. Before ending my presentation and on behalf of the project team, I would like to express my sincere thanks to the Feed the Future, USAID, Royal University of Agriculture, General Directorate of Agriculture, ISA Project, University of Illinois at Urbana-Champaign, CIRAD, Swiss Contact, SIIL, and Kansas State University. Thanks for your listening.
Okay, thank you again, Dr. Theng, for that excellent presentation that you provided. For the sake of time, we are going to make a slight change to the agenda. We were originally supposed to have a question and answer period after each presentation, but at this time I will share the presentation from Dr. Monjurul alum from our Bangladesh partners. And after his presentation, we will then have a brief question and answer period. However, I ask that both Dr. Theng and Dr. Alum and their respective teams, please pay attention to the chat feature, as participants may be asking questions throughout your presentation in there. And I encourage all participants to use that chat feature so that we can save time and get back on schedule. But at this time, I will share Dr. Monjurul alum's presentation. So please enjoy.
Distinguished
participants, ladies and gentlemen, good morning. This is Monjurul, Project Director, ASMC Bangladesh and Professor, Bangladesh Agricultural University. Welcoming you all to my presentation on Appropriate Scale Mechanization Innovation Hub, ASMC Bangladesh. The ASMC Bangladesh project is being implemented by Bangladesh Agricultural University in collaboration with Bangladesh Agricultural Research Institute and ACI Motors Limited. The portfolios of my research colleagues are shown here. In this presentation, I will be limited to the background, impact of phase 1 key activities, anticipated impact of phase 2, completed and ongoing activities of phase 2, critical challenges and mitigation measures, collaborating strategies, and acknowledgement. Ladies and gentlemen, let us start with the context of ASMC Bangladesh intervention. Appropriate Scale Mechanization Innovation Hub Bangladesh, sponsored by the Fit the Future, USAID and Sustainable Intensification Innovation Lab SIIL, has been implemented since 2015 as a part of and in the line of Appropriate Scale Mechanization Consortium, ASMC, University of Illinois, goals and objectives for overcoming the challenges in the southern delta of Bangladesh. Agriculture in this region is characterized by low productivity due to salinity, waterlogging, less access to modern technologies, inadequate control over water resources, and repeated crop losses due to natural calamities. The project intervention areas are shown in Bangladesh map. Let me introduce you with the goals and the key impacts of phase 1. The goal of ASMC Bangladesh phase 1 was to promote appropriate scale mechanization for sustainable intensification, focusing on smallholder farmers on farm operations and to improve land and labor productivity in a sustainable manner, considering the social, economic, and environmental impacts with special focus on the role of women. The key impacts are identified and scale appropriate technologies. The selected technologies are shown in the picture. Develop training and business modules, gender profiles, and videos on selected technologies. The link of the videos are given at the bottom of the slide. Develop entrepreneurship for customized service of agricultural machinery and contributed in policy change for government subsidy program. ASMC phase 1 project has contributed significantly in shifting focus from mini combine to combine harvester. At the initial years of ASMC Bangladesh, the project identified 2 harvesting machinery, dipper and mini combine harvester. After having information from on-farm test results, financial and business assessment, and feedback from local service providers and farmers, the project identified that after 1 year of operation, the operating cost of the mini combine harvester has gone up. This is because of this high repair and maintenance cost. At this background, the ASMC Bangladesh, in collaboration with a private company, ACI Motors, identified 2 small to medium-sized combined harvester models and tested those models in Bangladesh condition, and the project found those models are really good in performance and can be sustained in Bangladesh condition. At this point, ASMC Bangladesh, in collaboration with a private company and Department of Agricultural Extension, approached Ministry of Agriculture for this shift of focus from mini combine to combine harvester. The Ministry of Agriculture agreed with the proposition and decided to provide subsidy on combine harvester at a rate of 50 to 70%. During COVID-19 pandemic situation 2020, the ministry implemented subsidy program worth USD 23.81 million for promoting dipper and combine harvester. At present, the ministry is also implementing a subsidy program worth USD 3.6 billion in agricultural machinery, and that will be implemented in the next 5 years. All the selected machinery by the ASPI project have been included in this program. ASPI Bangladesh holds an annual workshop on 23rd September 2020. About 160 participants from around the globe attended the workshop. Dr. Muhammad Abdul Razak MP, Honorable Minister of Agriculture, Government of the People's Republic of Bangladesh, attended the workshop as the chief guest. In his deliberation, he expressed that agricultural mechanization is one of the top agendas of Bangladesh government. The government is providing 50 to 70% incentive to the farmers and entrepreneurs for purchasing agricultural machinery and to promote agricultural mechanization. Ladies and gentlemen, I'd like to introduce you with the goals, objectives, and the activities of ASPI Phase 2. The overall goal of the ASPI Bangladesh Phase 2 is to facilitate the development and deployment of transformational technologies in the southern delta of Bangladesh for sustainable intensification of 1,250 smallholder farmers and 1,250 hectares of land, which will be ultimately result in increased farm productivity and household income while empowering women and engaging youth. The objectives are scale selected transformational technologies in the southern delta of Bangladesh, build technical and entrepreneurial capacity of service providers and fabricators, empower women and engage youth in mechanized agriculture, and another policy environment for mechanization. The project intends to scale few selected technologies. They are rice transplanter, 2- and 4-wheel tractor-based seed planter, dipper, combine harvester, and BOS STR dryer. The project also intends to establish one-stop single shed service provisions by individual entrepreneurs or farmers group, a technology park in collaboration with ACI Motors Limited, a CA park in collaboration with BRI, SIIL, a smart agro technology innovation network in the light of Paris, Illinois. The project also established partnership with the SIIL holder activity in Bangladesh, and the planned activities for folder 29 are machinery intervention in transplanting, seed planting, and harvesting. Now also the capacity building and strengthening the agro entrepreneurship. Let us talk about the anticipated scaling pathway of this. The project intends to scaling of identified technologies through capacity building of potential service providers, operators, mechanics, and farmers, and establishing single shed service center for one-stop machinery service to farmers. The project also encompasses gender and youth engagement, agricultural mechanization. The project intends to establish CA park for demonstrating CA practices to relevant stakeholders, technology park for demonstrating appropriate agricultural mechanizations to relevant stakeholders, and overall policy environments for enabling environment of agricultural mechanization. The completed and ongoing activities of this. The project provided machinery services to farmers with a field coverage of 70 hectares in last harvesting season. The project also conducted 3 hands-on trainings on dipper and combine harvester, conducted 3 gender sensitization and 1 entrepreneurship development training, technology readiness assessment, TRA, and scaling gap analysis tools have been developed for BOS dryer, seed planter, and combine harvester. And so far, the workshop on BOS dryer has been completed. The project would like to involve youth with agricultural mechanization. In that view, the project already established Smart Agro-Technology Innovation Youth Network, acronym SIIL, in collaboration with Reyes, Illinois. This network is knowledge-based learning platform for teenagers and youths, where they can explore and boost their interest on smart and innovative agro-technologies. 8 agricultural and science and technology universities have already been consented to be the member of the network. The project already established a conservation agricultural park at Bangladesh Agricultural Research Institute, Kajipur. The pictures are shown here. A solar pump is installed in the CA park for green energy irrigation, and a tractor operated seed planter is developed for planting maize, barley, chickpea, and mungbean. The project also like to strengthen the single shed service provision for farmers. Motin Baidari, a service provider at Kolapara of Patuakhali district, had purchased a Yanmar combine harvester from the government subsidy program. He provides one-stop single shed customer service to farmers. The ASMI Bangladesh project is providing hands-on training and season-long mentoring to service providers. The pictures of handover a combine harvester and hands-on trainings are shown here. Since October 2020, the project published 3 research articles in journal and international journals. A presentation has been made in the BU Research System Annual Workshop 2021, and another presentation will be made in the ASABE Annual International Meeting 2021. Critical challenges and mitigation measures. COVID-19 pandemic situation impacted heavily on the activities of ASMI Bangladesh, and it already slowed down the implementation of the project activities. As mitigation measure, the project adopted combination of virtual and physical approaches for conduct training session. This virtual and physical approach that sets up training session pictures has been given in this slide. Let me introduce you with this collaboration strategies of the project for sustainable impact. The project already developed collaboration with the university, public sector, research institute, private sector, and local workshops. Bangladesh Agricultural University will lead research and knowledge and technology generation in ag mechanization. Department of Agricultural Extension will lead extension and dissemination of appropriate technologies and machines through government incentive programs on ag mechanization. Bangladesh Agricultural Research Institute will promote CA technologies and practices through CA Park. ACI Motor Limited will promote nationwide marketing of agricultural machineries and dissemination of ag mechanization through technology park. Local workshops, Mahabub Engineering, ADI, etc., will fabricate locally developed machines in collaboration with university and research institute. I like to acknowledge the contribution of Fit the Future, USAID, SIIL, Kansas State University, University of Illinois, Bangladesh Agricultural University, Bangladesh Agricultural Research Institute, Department of Agricultural Extension, ACI Motors, and Metal for their significant contribution in implementing and achieving the goals and objectives of this research. Ladies and gentlemen, thank you very much for your patience here. Thank you.
Okay, thank you very much, Dr. Alum, for that excellent presentation that you have shared. This is very informative, and we're very excited to see the work that is being done in Bangladesh. At this time, I believe that we will have a brief question and answer period for both our Cambodia group and our Bangladesh group. If you have any questions, you may use the chat feature, or raise your hand, and our project leaders will do their best to address all questions. We will take no more than 5 to 10 minutes for this question and answer period, and then we'll take a brief break before beginning our second half of the session. And if we do not have any questions,
Professor Singh has raised hand.
oh, okay, go ahead, Dr. Singh.
Yes. In Bangladesh, what is the main reason for shifting from reaper to big combine harvester?
Thank you, sir. Do you hear me, sir?
Yeah. How are you,
Yeah.
Dr. Alam? Go ahead.
Yes, please, sir. You know that Bangladesh actually uses the reaper as well as the combined harvester. We are going to, it's because, you know, in some areas, the people actually like to have the long straw. So in that case, especially in the almond crop, you know, you have knowledge, the almond paddy. So the people use the reaper to have a longer straw length. But when the borrow is usually, you know, it is the rainy days in May, April, and the May, which is start raining. So people do not look for this straw. So they can actually harvest it from the top. So that's why they are looking for the combined harvester to just actually you know, that is harvest it, then thresh it, and have the clean actually material. Now, even though this, you know, this head fit combined harvester, they actually having a longer straw as well, but only threshing the, you know, the panicles portion, and the rest is left behind in a synchronized way. So that's why the people in some areas are looking, especially, and another reason, you know, especially in the low-lying areas of Bangladesh, we call it Haur area. So the people have very small time to harvest, as because the flush from India, it is coming to Bangladesh. So people at that area, they are looking for the combined harvester to have this harvesting very quickly in a short time, so that they can save their actually crop, not the actually the straw and other things. That's why we are promoting both. Wherever it is needed, the you know, the reaper, and wherever it is needed, the combined harvester. But our experience with the mini combined harvester is not good, and that's why we actually you know, actually with our colleagues, we talked to the Ministry of Agriculture, and Ministry of Agriculture has changed this policy to promote this small to medium sized combined. Thank you, sir.
Thank you, Dr. Lum. Dr. Prasad, you had your hand raised next, so please proceed with your question.
Looks like Leighton is frozen. So while he unmutes, I wanted to ask a question to Cambodia team. And thank you very much for both Cambodia and Bangladesh team for excellent presentation, enjoyed it. And thanks Bangladesh team, Dr. Alam and Dr. Chayan for answering the questions in the chat. My question is for Dr. Theng of Cambodia team. You have shown us many technologies or machineries. I know some of you are showing it in the Buckner Technology Park, but I was just wondering, are you thinking about expanding and showcasing these technologies beyond the Buckner? Because it's difficult to bring all the farmers to Buckner, so it would be nice to have one in the south and also one in the northern region. Thank you very much.
Dr. Theng, were you able to hear that question?
Excuse me, sorry again. I just written the message in chat to Dr. Prasad, and I couldn't catch his voice.
Okay. I'll
Yeah.
ask Dr. Prasad, will you ask that one more time for Dr. Theng? Dr. Prasad, Dina
Yes.
asked if you would be able to ask that question again. He did not hear it the first time.
Oh, okay. Thank you, Dr. Theng. I was going to ask that machinery which you showcase regularly in Buckner. I was wondering if you are also thinking about showcasing in another technology park in the south or in the northern part, because it's difficult to bring all the farmers to show in Buckner.
Okay, thank you. Yeah, actually, at the technology park in Burkina, the team from CAS and from CSEN is showcasing regularly. And from phase one, we also plan to provide showcase in other technology park, including in the university campus. But generally the land size for the tech park is small. It's not appropriate for the machinery for cash crop or for rice. But for vegetable is okay. However, the vegetable is conducted by the team from National University of Battambang, that they provide in Banan and also in the Tech Park in Battambang.
Thank you.
Hello, may I have a comment on the question of Dr. Vara? So as we know that the Buckner Center is the research site that one of the main component is for designing and assessing the cropping system on the conservation agriculture practices. However, to avoid the transportation or mobilizing farmers who are interested in applying the conservation agriculture to their own farm, we already set up on-farm network scattered in our village area, and through the process of identify volunteer farmer who are interested in applying the innovative conservation agriculture system. Then we set up this network in order to organize the capacity building, even through organizing field day, demarcation, or other showcase of the appropriate scale machinery used for conservation agriculture, or directly on this on-farm network. And beside this on-farm network, we also set up we call early adapter that take part of the key element for conservation agriculture practices on their own farm. So all in all, you can imagine that we create a network of the different scale of adaptation in the community level. So this network not only serve as the showcase for the technology adaptation, but also as the farmer field school for regular exchange on the capacity building and experience sharing between the farmer network in the community itself. And also it provides a feedback on the adjustment of the cropping system and challenging that as the researcher have to modify to fit well with their own context at the community community level, based on the agro ecosystem, soil type, and financial capacity of each individual. Thank you.
Yeah, thanks, Vira. There was another question in the chat box which was asking, I think it's coming from Dr. Ayub Hussain from Bari. He was asking what percentage of land area is under conservation agriculture, in Cambodia. So maybe one of you, the Cambodian team, can answer. Thanks.
So let me respond to this. Although Cambodia has the long-term experience on the research on the conservation agriculture as presented by Dr. Manny. However, the scale up very recently through the support of the SIIL and other public funding like AFD and SDC, through the engagement of the private sector into the scaling up of the CA processes. So I would say that the cultivated area and the number of farmers who are adopting is quite least in comparison with the arable land of the countries. However, it is called that, you know, the transition, and we just set up several sites as the pilot for the extension of conservation agriculture. So let's say that the cultivated area remain marginal, and we are seeking, you know, the way that to scaling up it based on the context of smallholder farmer, and we take into account different stakeholder and also supporting mechanism to identify the best extension strategy for the mass scaling in the near future. So beside the research activity and extension activity, we are at the junior stage at SIIL, and we hope that through collaborative with our partner, we will bring it to scale, and we will also disseminate this extension model to our neighboring country as well. Thank you.
Okay, excellent. Thank you, Vera. At this time, we will take a short break. I know the agenda says 10-minute break, but for the sake of time, I think it will be wise if we will just take a 5-minute break before proceeding with presentations from our West Africa partners. So after this break, we will hear from Dr. Ajit Srivastava. But at this time, we will take a 5-minute break. And so at approximately 9:27 Central Daylight Standard Time, we will resume. During our break, I've asked our partners to provide some music that they enjoy. And so our Bangladesh and Cambodia partners have provided a few songs that I will be playing during our break. But please take a quick break, and I will see you in about 5 minutes. Thank you, everyone. It is time to resume the meeting. So at this time, I will begin by introducing our next speaker. But before I do, I would like to just remind everyone, please keep your microphones and cameras off, unless, of course, you are the one asking or answering questions. But at this time, we'll hear from our West Africa Regional Coordinator, Dr. Ajit Srivastava. Dr. Srivastava is a professor in biosystems and agricultural engineering at Michigan State University. His research interests lie in agricultural mechanization, and he has published extensively in this area, including a textbook titled Engineering Principles of Agricultural Machines. He has served as the Burkina Faso country coordinator for the ASMC Phase 1 project and has developed technologies such as a solar-powered two-wheel tractor and a solar drip irrigation system to grow crops during the dry season. He is now serving as the coordinator for the ASMC West Africa Innovation Hub in Senegal. In addition to coordinating activities such as technology innovation, scaling, gender and youth engagement, and capacity building, he collaborates with ASMC partner institutions and organizations to meet the goals and objectives of the project. The floor is now yours, Dr. Srivastava.
Thank you, Leighton. Let me share my screen. Can you see my screen?
Yes.
Okay. Just a second. Okay, well, thank you very much for the nice introduction. I will give you a very brief overview of the ASMC Innovation Hub in West Africa. As you can see from the diagram, the region includes many, many countries. We have been working in Burkina Faso. We are proposing to set up a innovation hub in Senegal in phase 2. And the role of the hub would be to address mechanization needs in the region and in other countries as well that are linked with SIIL projects such as Niger and Mali. Our team includes, of course, myself, and I'm the US coordinator of the West Africa Hub. Dr. Tim Harrigan, he's associate professor in biosystems and ag engineering at Michigan State. His expertise is draft animal mechanization, also cropping systems work, and extension. And he has been extremely valuable member of the team in taking a participatory cropping systems approach to mechanization. Dr. Nanda Joshi is associate professor of animal science, and his expertise is animal nutrition. And of course, as you can see in mechanization, where we have draft animal as a source of power, animal nutrition and health is very important. And he has been providing tremendous leadership in that area. In phase 2, we are very fortunate to have Dr. Ranjani Krishnan join our team as we focus more on technology scaling. She is an endowed chair in accounting at the MSU College of Management. And her area of expertise is entrepreneurship, business development, and she has done quite a bit of work in microfinancing for women in India. We have a great relationship with Tillers International. It's a nonprofit organization located in Scott, Michigan. And Robert Burdick, who is now serving as the director of the organization, bringing tremendous experience in mechanization, especially in training artisans to develop mechanization in Africa. He has worked in Uganda, Ethiopia, very heavily involved in Mozambique, as well as in our project in Senegal and in Burkina Faso. We're also claiming Maria Jones, although she is part of the project in Illinois, but she has been working very closely with our team, particularly addressing women empowerment issues. So we really appreciate her contributions. Our in-country directors are Dr. Vinsoun Millogo, with whom we have been working over the last 4 years. He's an animal scientist, and he has done a tremendous job in leading the efforts in Burkina Faso. We are working with Dr. Aliou Faye, who is a research scientist with CIRAS and ISRA in Senegal. And we have already started working on various aspects of the project in Senegal. The goal of our West Africa hub is to scale appropriate scale transformational mechanization technologies to 5,000 farmers or 5,000 hectares of land in the West Africa region. Our mission is to develop and scale appropriate mechanization to support smallholder farmers in West Africa to become productive and profitable enterprise. And I want to emphasize the word profitable enterprise. We are trying to move forward beyond subsistence farming. So it's not just a matter of food security, it's a matter of actually transforming small scale holder farmers to become small enterprises. So that will lead to poverty reduction, and improvement of quality of life. So we really think that is an important mission. Our vision is to create an ecosystem of innovation in the region, working in close collaboration with various stakeholders and partner organizations to obtain continued funding to support entrepreneurial activities that lead to the development, adoption, and scaling of innovative technologies through capacity building, women empowerment, and youth engagement. West Africa Hub is not an island by itself. We recognize that to be successful, we must collaborate with many entities and organizations. Initially, we proposed to collaborate very closely with CORAF and iReach. Actually, we have already begun a conversation with iReach in how to scale technology. And on July 1st, we'll be holding a call with their management or the advisory committee to address some of those issues. We will be working with projects like Africa Rising, working with educational institutions such as University of Chess, government organizations such as ISRA and SIRAS, private sectors, and we'll be focusing on agro-pastoral system and cereal root crop mixed cropping system. We will begin with, actually we have already started that, assessing the needs for technology and scaling, identifying technology innovation and scaling. We'll focus on business development and entrepreneurship, look at capacity building, also look at policy infrastructure. And I should take a moment here to emphasize the successes that Bangladesh team has shown in influencing policies, and we would like to learn from them as to how we can influence policy so we can provide appropriate subsidies and infrastructure to promote scaling. We will look at impact and also knowledge sharing and dissemination. So with that, I did not go into the details of what we have done in Burkina Faso and what we plan to do in Senegal. I will let the team leaders over there mention that. I would mention that we are extremely thankful to be part of this project. We appreciate the support of USAID Feed the Future program and support from the Sustainable Intensification Innovation Lab and also from the ASMC in University of Illinois. Thank you very much.
Thank you very much, Dr. Srivastava. That was an excellent introduction. And I will now show Dr. Vinsoun Millogo's presentation. He is from our, he will be representing our Burkina Faso group. Dr. Srivastava, will you stop your screen share at this time?
Yes.
No worries. Okay.
Good morning, ladies and gentlemen, SIIL and ASMC member. I am Vinsoun Millogo, Innovation Hub Director in Burkina Faso and Associate Professor from Nasibuni University. I would like to present on behalf of my team ASMC implementation in Burkina Faso phase 2 in this Inception meeting. And my introduction will focus mainly on food security data as we see, and 44% of population in Burkina Faso are under poverty line, and almost 80% are involved in the rural area activities, and also children are under acute malnutrition condition, and also women and children suffer from anemia. Those are slightly food security data. The second introduction I would like to show you is agroecological zone in Burkina Faso. We have three main areas. The first is South Sudan, where we can grow crops, cereal, and cotton. And the second zone is North Sudan, where subsistence and cereal farming system is implementing. And the last one is agro-pastoral system, where we have most livestock in the north. And based on agriculture economy, Burkina Faso is mainly agro-pastoral economy. 40% from the group domestic products and population involved mainly in small holding farming system. And also this area is mechanization is not well developed, and livestock sector is underdeveloped, and also soil is the degradation of soil is soil are degraded, and also poor post-harvest storage technique, limit to access credit, finance, input, including seed, especially for women. And the agricultural product are main crops and livestock, and the market is of course Burkina Faso, and also Mali, Niger, Senegal. Livestock is going to Ivory Coast, Ghana, Benin, Senegal, but the soybean start to go to Nigeria right now, where there is a lot of demand on soybean from Burkina Faso. USAID recommendation can be understood in two main points: transforming smallholder farming agriculture from subsistence area farming to integrate food and cash production, and strengthen integration of livestock and policy ownership in smallholder production. Focus and improve natural resources management technique. And from that recommendation, we can keep some key points. Agriculture in Burkina Faso is the main challenge for development, and there is a lot of opportunities for mechanization. It is critical to understand farming cropping system, and also animal power is still a potential to scale up a lot of mechanization intervention in Burkina Faso. And it's necessary to take an integrated approach to integrate cropping and also livestock production. And from phase one, the goal was to assist smallholder farmers to integrate approach-scale mechanization to produce crop and also livestock. And the objective of the phase one was to develop a system of mechanization for sustainable intensification of maize production in the Haut Bassin area, which was the project area. And second, to improve animal nutrition and comfort as source of drug power for mechanization, and also to address household nutrition by growing crop during the dry season. And the team member, there is coordinator, innovation hub director, and operating manager, gender specialist, and also tech assessment manager, and also cropping system specialist, mechanization specialist, and also accountant. And the significant achievement from phase one, we can summarize the work we have done. We start with a baseline survey, and we set up an innovation demonstration seat at Leaf Farm, and also we try to identify the key gender issue. First is reduce drudgery from farm work, improve household nutrition, and as I showed in the introduction, improve access to credit. And the main achievement is first is we improve soil repair for conservative tillage, maize planter, wheat cultivator, and also ergonomic yoke, make a yoke to improve the draft animal working condition, and also we also work with animal to organize the low stress for animals, and also we make a forest chopper and silage making, and we can also keep in mind solar duplication that was developed to grow crops and also seed crop and also vegetable for family, smallholder family nutrition. And other significant achievement is the gender and youth engagement. The approach of the ICMC in Burkina Faso will include women in all process and also in the design and application test of the equipment. And this is the example you can see. The women are now using the ICMC innovation, especially planter and chopper. And youth also, ICMC focus on youth engagement. First, as a higher education research institution, we include a student. We train more than 20 students and also a master student. As we see the picture, this is Uda Sampo, who is now engineer of rural development, especially crop production, and working now as a businessman, and also helping ICMC to implement and scale up innovation. And other significant achievement is our attendance to symposium in the capital of Burkina Faso, Ouagadougou, where the Minister of Agriculture and other central authorities came and visited ICMC planter and appreciate a lot of this innovation. For the second phase, the objective of the phase and the goal first, and then the objective. The goal is to scale selective technology, as I show you, to reach 2,500 farmers or 2,500 hectares of land. And the objective, the specific objective are first, research technology readiness, as I presented in phase 1. Second, scale up adoption, and also identify gender employment and youth engagement, and build capacity through training and education, both students, farmers, and other businessmen, to understand the role of the ICMC innovation in Burkina Faso. And the last one, share knowledge and disseminate information through publication and or other scientific articles. And we start with gap analysis, in which we try to understand what is the gap between a user, potential user, and other people who work with the planter. That's why you see picture, we make a record, and now we are running statistic. And for this phase 2, we are going to scale up maize planter first, second, forest chopper, and also solar drip irrigation, which means we have mainly 2 innovation we want to scale up in this, and we start already to scale up the planter, the chopper, and the drip irrigation will also be included in the phase, in the scaling process of phase 2. And to conclude the pathway of scaling and impact, and this is we just repeat the work plan, technical readiness assessment, and also we are organized right now because this is the growing, starting growing season in Burkina Faso, the planting season. We are now starting to organize farming field day. Farming field day means when a farmer is using the innovation, he invites another farmer to check how the technology is working properly on field. And sometimes the ICMC team member can also help students and other people. For its training time is also exchange to understand which kind of problem farmers are meeting by using the innovation. And as we see, we plan a capacity building again there as I show you. And also we plan to organize a conference on mechanization and also to attend to symposium, workshop, sharing meeting, and of course make a lot of report work in Piasta for SIIL and also publication and also in social media in both national TV to show how important is ASMC phase 1 innovation and how those innovations can impact Burkina Faso and also West Africa, but because now we are working in a regional innovation hub with Senegal and other West African countries, and we appreciate that. We would like to end my talk by thanking SIIL people, ICB gold member, and also US government for helping Burkina Faso and also Nazibon University to develop and also learn a lot from by carrying out projects and other things. I would like to thank you for your attention and thank you very much. And if there is question, do not hesitate to ask. We are open, and also we are ready to answer, and the rest of my colleagues can also answer the question. Thank you very much for your attention.
Okay, thank you, Dr. Millogo, for that excellent presentation. Similar to how we conducted the question and answer session for the Asia Regional Innovation Hub and our Cambodia and Bangladesh presentations, we are going to combine the question and answer period for Burkina Faso and Senegal. Again, I recommend that if you do have a question, please utilize the chat feature to ask your question. And I ask that Dr. Millogo and the rest of his team, as well as Dr. Faye and his team, to be monitoring the chat to see if any questions do arise. But at this time, I will now show Dr. Aliou Faye's presentation for Senegal.
Good morning. My name is Aliou Faye. I'm a scientist at the Regional Center of Excellence on Dry Cereal Associate Crop, and I'm presenting the West Africa Agricultural Mechanization Hub of the Appropriate Scale Mechanization Consortium for Sustainable Intensification. I will start by presenting the team of the project. Myself, Aliou Faye, the agronomist, Dr. Demba Diakhaté, mechanization specialist, Pap Madiama Diop, agricultural mechanization engineer, and Malik Chow, a BSc student from ISFAR, University of Bombay. As a partner, we have Professor Sheikh Chow at University of Kaolack, Professor Jeju, University of Thiès, Reyes, the Senegalese Artisan Network for Rebuilding Soils, Dr. Niroj Lamia at IRAF, the Irish manager at Koraf, Madame Binte Dieng, Extension Services at Thiès, Abdullah Ndour, Farmers Organization at Thiès, and Ndeifatu Jaimane, Innovation Dissemination Specialist at ISRA. So our project is targeting the peanut basin of Kaolack, namely the region of Kaolack, Fatin, and Kafrin, as shown in this map. So for planned activity, ongoing activity, we will establish a West Africa Mechanization Hub Advisory Committee. We will showcase technology at USAID SIIL Koraf Seras Agtechport. We will develop and test pertinent mechanization technology, including composting and compost application, planter compost application, forage chopping, solar power traction unit, solar drip irrigation. We also will build capacity and work on gender empowerment and youth engagement, share knowledge and information. Some activities have been already accomplished. So for example, Michigan State Biosystem Engineering students have developed a set for design of a low-cost compost tunnel This option design will be built and test and technology park. We also have some visits that have been already done. Michigan State team visited Senegal in 2018 and 2019. Illinois team also visited Senegal in 2020. I also got the opportunity to visit Michigan State and learn more about the electric two-wheel tractor units. And a group of artisans were trained to build a forage chopper in Saint-Louis in Senegal by Dr. Tim Harrigan and Robert Birdy in March 2020. Also, we complete a manual plus manual study in Senegal. As a justification, we know that in sub-Saharan Africa, 6% of arable land are degraded, and we are facing a lot of nutrient loss up to 60 kg per hectare. But we know that manure improves soil physical, chemical, and biological quality. The problem is the method of storage of manure, as well as applying in field broadcasting lead to nutrient loss. Some studies have already shown that by burying the manure, we can reduce significantly the quantity while increasing the crop yield as compared to the control. As such, manure application and planter have been developed, but still need improvement. So the objective of this study was to evaluate the effect of manure compost fertilizer placement in soil proximity to the seed for optimal seed germination and biomass accumulation as compared to traditional on-farm surface manure broadcasting. As a methodology, we collected soil from farm in Senegal, Bombay. We filled 10 kg with the soil after calculating the water holding capacity, and we arranged it in a split plot with 3 replicate and 2 factors, the water regime as a secondary factor and the seed and fertilizer plasma as a main factor. We use symmetry as a millet variety, and we designed 8 fertilizer treatment as follows. The first one was the standard farmers practice of 8 tons per hectare of manure broadcast before seeding. Seed at 10 centimeters in soil mixed with manure equivalent to 1/4 of the NPK content. Manure at 10 centimeters below seed mixed with 1/4 of NPK content. Seed at this 10 centimeters beside manure equivalent to 1/4 of NPK content. And seed at 10 centimeters in soil with a full rate of NPK millet dose recommendation. Seed at 10 centimeters in soil with 1/2 of the NPK millet dose recommendation. Seed of over manure equivalent to 1/2 of NPK content. And at the end list and find the seed in soil with 1/2 of NPK millet recommendation dose rate plus 1/2 of manure quality of equivalent to the half of NPK content. As a main result, we on seed germination, plant height, plant tillering, reed biomass, and shoot biomass. For water regime, we didn't have a significant effect on seed germination, plant height, root biomass from biomass forming and shoot biomass forming, but we have significant effect on plant tillering. For treatment effects, we have significant effect on seed germination, especially we observe that it relates to significant low seed germination, while for plant height, we had a highly significant effect with T1 having the highest plant height level, and for tiller forming also T1 showed best result with T1, and for root dry biomass we didn't have any significant effect. However, for shoot dry biomass of plant we had a significant effect of the treatment with the lowest effect in T2, T4, and T7. For seed germination and plant tillering, for seed germination according to water regime, In normal condition and in stress conditions, the treatment gives the lowest seed germination. For plant tillering, for the T1 also give the highest plant tillering. For root and shoot biomass forming, according to water regime, in normal conditions, the root biomass, highest root biomass was observed in T1 and T8, while for stress condition, the highest root dry biomass was observed with T5 and T8. Regarding to shoot dry biomass, in normal conditions, the highest shoot dry biomass was observed in T1, followed by T6 and T8, while for stress conditions, the highest shoot dry biomass was observed in T1, T5, and T8. This result was defined in a BSc thesis at the University of Bombay by Malik Chow. For planning capacity building activity, we've been engaged with ENSA and the University of Kaolack to implement educational and training program to develop workforce needed to support the emerging mechanization industry. We will engage with artisan organizations to develop ongoing training and certification with the help of CFPAB in Burkina Faso. We also will develop training and educational materials such as online training material, brochure, poster, and poster. We will collaborate with Reform to develop opportunity for self-training in West Africa Health. Planned gender and youth engagement activity will include gender and gender's perspective at every stage of technology, innovation, development, and testing. We will conduct a technology assessment from gender's perspective. We will develop and implement youth engagement programs similar to the Forage program in the US. For knowledge sharing and dissemination, we will create a suitable database of appropriate technology in the region. A good start will be to digitalize documents available at Senera Bambé in Senegal, and also collaborate with FAO to continue to update this database. We also will publish articles in peer-reviewed journal, popular magazine, and present paper and conferences. We also have already a potential advisory committee members that will be led by Dr. Alin Fall, who is a former Director General of ISRA, and in this list you will see all the members of this committee. All of them have been contacted and give their agreement to be part of this committee. Thank you for your kind attention.
Thank you very much, Dr. Faye, for sharing that excellent presentation. And we are very excited to have you as part of ASMC Phase 2. We're excited to see how our connection in Senegal, and excited to see all of the progress that you will make under your leadership. At this time, we will now have a 10-minute question and answer period for both of our Burkina Faso and Senegal presenters. So I ask that Dr. Millogo and Dr. Faye please monitor the chat, and also I will monitor the chat as well. And if you have any questions, you can place them there or raise your hand, and we'll try to get through as many questions as we can. I know that Dr. Faye is having connection issues, so he may have dropped connection, but I'm sure he'll be trying to join back onto the meeting. But again, you can place your questions in chat, and we will try to get all questions addressed. Thank you. Dr. Faye, it looks like Dr. Prasad has a question. He has placed it in the chat, but Dr. Prasad, you have your hand raised. If you want to ask it verbally, that's perfectly fine too. So go ahead with your question.
Thanks, Leighton. Just for easy for Aliou, I will ask the question. Thanks for your presentation, Aliou. I was wondering, who are your private sector partners? And then are you going to do the technology assessment as the Burkina team is doing? And then what technologies from mechanization perspective are you thinking of showcasing at the SIIL Technology Park? Thank you.
Yeah, good morning, good afternoon, everybody. Thank you, Vara, for your question. So definitely we are working with private sector in Senegal, like we are working with Matforce. We already talking with them to see what kind of machinery they will we can work with. And I know that, as I show in the chat also, we have been working already with Tiller International and Robert on building the Czapar. And we also have been, we contacted also on ASI, the program who was working at chess for the mill, the multifunctional mill machine that will be showing in the technology park. And with Dr. Ajit also, we are thinking about the solar drive irrigation. So we have several machinery that we want to show in the technology park. Yeah, sure. So as I said, also we will be working closely with Burkina, since they already have been working with ASMC and develop some technology, and we are trying to see which technology will be also well adapted in Senegal technology, like the Czapar that we already started disseminating in Senegal. Thank you.
Thank you, Dr. Faye.
If I could just make a comment, I think, Aliou, I think that those are great, but I would certainly encourage you to do the technology assessment and develop an impact pathway and identify the scaling partners. Those three are going to be very critical as you move forward. Thank you.
Yeah, thank you again. I think that we have been also working with Dr. Ajit to the technology assessment. We are already working on it, and as we said, we will do it. We started working with Dr. Ajit on the protocol to use for the technology assessment. And I know that also Maria Jones is working with Madam J on also how agricultural technology and women and gender issues. So we are also working with Maria on developing a protocol to evaluate the gender assessment in agricultural mechanization. So yeah, we are effectively working on 2 aspects. Just that maybe we just started the program very recently, working on that.
Okay, thank you. Professor Singh, it looks like you're next for a question. You can proceed.
Yeah, thank you. Thank you, Ajit, for excellent presentation and your team. I'm very much thinking of using more of solar energy, which Ajit has already introduced the idea, not only for irrigation, drip irrigation, but all other stationary operations in post-harvest area. I think the solar energy is available plenty in all over Africa, especially West Africa. And this technology is becoming very convenient. And as a matter of fact, it's much easier than the engines. Motors are easier to operate than engines because engines maintenance is much more difficult than the electric motors. So I like to see that rather than going through a big system of internal combustion engines approach, maybe we can try to move to the battery-driven small equipment, including drip irrigation. Thank you.
If I can respond to that.
Absolutely, go ahead.
Yeah, so I think Gajendra is bringing a very important point, and the two-wheel solar power traction unit that we have developed, it does two things. Definitely provides power for farm equipment such as tillage and planting, but it is also a mobile power unit for other operations, stationary operations such as milling, grinding, and such. And you simply have to just plug in the equipment into it, and it will provide the power. So, and also lighting for household. So we are moving in that direction because tillage and planting, they're very small in terms of time use of a machine. But if we can expand the use to other applications, such as Gajendra pointed out, then it becomes much more affordable and cost effective.
Leighton, can I ask a quick question?
Yes, I think we have time for one more question, and then we can proceed from there. So go ahead.
Thanks, Dr. Theng and Dr. Srivastava, for that part about using the solar power. I think it's an excellent. I saw your unit at Michigan State University. I was wondering, have you tested in the field to see the need for how long it would take to power it, and then how long it will last after the power, and then what would be the economics related to that? Thank you.
We have tested in the field in Michigan quite extensively, and it works really, really well. How long it lasts depends upon what is the intensity of load. It has a 200 amp hour capacity. So basically, if you are pulling a ripper or a single chisel plow, it can last 4 hours. There's a paper on this that we have presented in ASAB conference, and it gives all the field capacity and performance data there. In terms of charging, so basically it will take 4 hours to fully recharge with solar panels. So it takes 4 hours to discharge fully on a maximum load. It will take 4 hours to recharge, unless you have a high capacity charging system, which we would not recommend. So what we have to do is look at the total availability of sunshine, and then you have to look at what is the duration of time they're using in the field and how much time it will take to recharge it. And that would be a bit of a load management type of situation that we have to look at. But yes, it has been tested in field. It has worked well. And again, going back to what Manny Reyes was saying in terms of Ogun tractor, this is again an open source design. The components are all off the shelf, a component available anywhere. And that's the approach we are taking to introduce it into in Africa particularly. So this would be one of the things that we would like to showcase in the technology park in Senegal.
Thank you. Great.
Thank you.
Okay, thank you both for those excellent question and answer. So at this time, we will take another very quick break before we get to the final section of the meeting. So again, we will just take a 5-minute break. I know the agenda says 10 minutes, but I know we just recently took a break, and so we'll take just a quick break before coming back at, let's say, 10:20 Central Standard Time. So take about 5 minutes, and then we will reconvene at that time. Well, we are at 10:21 now, so we will now resume the meeting. Thank you to all our partners who have shared those excellent presentations, and for the discussion that we've had. It's been very productive. At this time, we will now hear from some of our co-PIs that have some specific research areas. We will first hear from Dr. Niroj Aryal. Dr. Aryal serves as a co-PI with expertise in environmental conservation and sustainability. He earned his bachelor's in biosystems engineering and PhD in biosystems and environmental engineering from Michigan State University. His research interests are in agricultural conservation, water quality, and hydrology. Dr. Aryal contributes to the formulation of the Sustainable Intensification Assessment Framework for implementation and assessment. He focuses on the sustainability of the introduced technologies, specifically with respect to the environmental footprint. And I will now share his presentation.
Hello everyone, my name is Niroj Aryal. I'm an assistant professor of biological engineering at North Carolina A&T State University. I'm going to talk about NCIG's role in phase second, which is specifically on sustainable intensification assessment framework. Just a little bit about me. I am an agricultural engineering by training. My PhD in biosystems and environmental engineering was from Michigan State University. My core areas of research are in water quality and ecological engineering. I seek solutions to both urban and agricultural water. My expertise relevant to ASMC is utilizing assessing agricultural waste management practices for water conservation and water quality protection. For ASMC phase which I was involved late. I visited Ethiopia. I provided training on conservation effects assessment. Also, I helped establish some transducer, flow meter, and plot switch to add to the Mazi Bumpy study to monitor well or outflow from the well. For phase 2, I hope to utilize sustainable intensification toolkit to assess the technology developed in phase first in countries, to guide measurement and evaluation, and also to compare with conventional practices by also working with partners and stakeholders. The SI toolkit, there are 6 steps, not necessarily linear. The first one is engage with stakeholders to develop objectives and sub-objectives. The second one is select indicators for each domain. There are 5 domains: productivity, economic, environmental, human condition, and social. And the scale can be at plot, farm, household, or landscape. Once identified the indicators, identify trade-offs and synergy, and again refine indicators as needed. The fourth one is select metrics, it's all about data collection and resource needed. The fifth one is analyzing the data collected, and the last one is sharing it with the stakeholders again and revising if necessary. This table shows the technology developed in ASMC phase first in countries, but minimum till planter, I have started working on it for SI toolkit. I would like to do solar drip irrigation system and composting system and more is identified by partners. Just as example, in draft stage for planter in Burkina Faso, maize planter in Burkina Faso, the objective can be, can the use of planter increase the farming system productivity, profitability, environmental sustainability of maize cropping, and reduce human physical stress of planting, and enhance gender involvement. Here are the indicators for each domain's productivity. It can be yield and variability of product itself. For environmental domain, can be soil health, weed, moisture retention, air pollution. For the economic domains, it can be income, labor, capital. For the human condition domain, it can be health and well-being, capacity developed. For the social, it can be gender engagement. The measurement method can be trial or experimentation, survey, results from models. The skills are the relevant skills for this technology is plot, farm, or household. These are the trade-offs and synergy. I thought capital and pesticides are needed, or emerging weeds, growth of weeds may be the negative side, maybe the trade-offs. This is blank because would be ideal to work with partner institutions to develop the data collection methods. I hope most of it has already been collected. So I would like to continue to work with partners, have dialogue, and come up with something that is shown on the right, which is a radar map. Thank you very much for your attention, and I very much welcome your input. Thank you.
Okay, thank you, Dr. Aryal, for your presentation. It looks like we have a question from Dr. Prasad. You may go ahead with your question.
Thank you, Niroj, for your presentation and interest in using SIIF. I would certainly encourage you to try it out and give us any feedback. And in addition to the software which you have, we have an online source as well. And we recently developed apps which can be utilized for both an Android phone and iOS platform. And you should be able to download it from the App Store, depending upon which phone you have. And please, it is testing. So please give us your feedback. It should have all the features which are available on the web in the app as well. So we're looking forward to hearing from you and anyone else in this group and others. Please use it and let us know how we can further improve it. The idea is to make it simple for use by researchers, but also from other people. So thank you for trying it out and looking forward to your feedback. Thanks.
Thank you, Dr. Prasad. It's great to know it's available in the app. I'll definitely use and communicate with you. Thank you very much.
Okay, excellent. We will now have our presentation by Dr. Krishnan and Dr. Hansen. A major achievement thus far in phase 2 is the development and launching of the technology readiness assessment and the scaling gap analysis. And this effort was led by Dr. Ranjani Krishnan with the assistance of Dr. Alan Hansen. Dr. Ranjani Krishnan is the Ernest W. and Robert W. Schauberg Endowed Chair in Accounting at Michigan State University. Dr. Krishnan's research focuses on issues related to managerial accounting, cost behavior, and performance measurement. She teaches courses in financial accounting, managerial accounting, strategic performance measurement, operational performance management, healthcare accounting, and value chain analytics in undergraduate, master's, executive MBA, MBA, and PhD, and executive education programs. She has also worked on corporate training programs with Fortune 500 companies. Dr. Alan Hansen's research creates innovative solutions to improve the operations of off-road machine systems. He led ASMC in phase 1 towards establishing innovation hubs and field hubs in Bangladesh, Cambodia, Ethiopia, and Burkina Faso. He has facilitated the development of appropriate scale technologies for smallholder farmers, especially women, targeting sustainable intensification of food production, benefiting the local environment and economic well-being of rural communities. I will now share their presentation on the technology readiness assessment and the scaling gap analysis.
The purpose of this segment is to summarize progress towards identifying the opportunities and impediments for scaling of technological innovations. Towards this goal, in the past year, we have identified efforts to collect quantitative and qualitative data from the field. And in this segment, we will summarize our efforts to date. So our progress so far is that we have developed quantitative and qualitative data collection instruments to understand multiple issues related to scaling, especially with respect to technology, human capital, and institutional gaps and opportunities. We have conducted training of field agents, and we have begun the data collection process, and we are in the process of identifying the patterns that are emerging from the data and the type of hurdles that we are observing. So in terms of assessment of scaling levels, we are using the following broad framework. The way technology or any type of innovation is scaled in the field is that there is first a beginning point where some farmers initiate the use. These are generally known as the first movers. They may be either influential farmers, or they may be related to the project team, or they may have already had identified other innovations that they have moved forward on. And then when these different initiatives start to gain momentum, multiple influential groups emerge. And then there is a critical mass where multiple stakeholder pools and institutions such as banks and governments and other manufacturers realize this potential, and formal initiatives are established. And the final phase is institutionalization, where these practices are perceived as normal by stakeholders, in the sense that a farmer believes that their farm is incomplete without the technology. So that is the life cycle of scaling. So far what we've done is we've developed instruments, we have identified target groups to administer the instruments, we have trained field agents, we have translated these instruments, we have pilot tested these instruments, we have recruited participants, we have conducted discussions, and we've collected data, and we are currently in the process of analyzing data. Once we analyze the data and do both quantitative and qualitative modeling of the data, we will be able to develop action plans with respect to the next steps to look at what can we do next to speed up the scaling process. So we developed two types of instruments. One is Technology Readiness Assessment Instrument, the TRA. This instrument, developed by Dr. Hansen, who will be speaking after me to explain the instrument, has already been tested in the field. So it's an established instrument which collects quantitative data from farmer users and non-users. In addition, we also developed a new instrument, the gap analysis, which collects qualitative data from farmer users and value chain members. We developed these instruments and we translated them into local languages. And in the next step, we identified target groups. We made sure that there was wide representation because as we know, scaling gaps may be more prevalent in one group than in the other. So we have male and female farmers, youth farmers, artisans, blacksmiths, political leaders, bureaucratic representatives, farmer cooperatives, local bankers, farm equipment suppliers, non-governmental organizations, and university representatives. And then after that, we trained and translated the instruments and pilot tested them. The field agents were graduate students, project team members. We conducted the pilots, and the sites in Burkina Faso, we had 3 sites, and in Bangladesh, we had 3 sites. So we pilot tested and then administered those instruments in those sites. So the gap analysis instrument is a 13-page qualitative instrument, and we first ran a one-day training program to train the trainers for qualitative data collection. A sample training agenda is provided here. We summarize the overall goals. We talked about the technology. We talked about the agenda for data collection. We did gender integration issues. We did some breakout groups, and then we concluded. In here, we see a sample of the training materials that we developed. We provided some background about how to collect quantitative and qualitative data, and this is just a sample of some of the materials we used. And then in terms of the implementation, we had two facilitators, one facilitator to ask the questions, one note taker. We allotted about 3 hours per group. We made sure that everyone talks, so the trainers were trained to look out for that. And we wanted to get some level of agreement or consensus on each question. For each question, we provided a narrative so that the data collection agents can determine whether scaling is easy, neutral, or harder. And this just provides a sample of how we provided a narrative for each question. Now, Dr. Hansen is going to talk about the technology readiness assessment tool that he administered. Thank you.
Thank you, Dr. Krishnan. So just to repeat, so as mentioned, a key objective for the ASMC in phase 2 is the scaling up of appropriate technologies that were identified or developed, tested, evaluated in each country in phase 1. And so the question is, how do we assess their relative level of readiness, sustainability, resilience for deployment on both a country and a regional basis? What sort of questions should we be asking? In terms of the objectives, so this was a 3-page quantitative instrument, and the objective was to perform a quantitative assessment, as has been already mentioned, of the potential adoption of technologies identified, tested, and evaluated in phase 1 of the project, and targeting very much current users and non-users of the technology. And the goal was to obtain information on the challenges for adoption from these groups. And the benefit of this approach was collecting quantifiable data using standardized questions. The topics covered in the questionnaires, or the questionnaire was obviously the respondent demographics was important to know, the technology effectiveness relative to performance in terms of productivity and work rate, the status of access to power sources for the technology, and also the relative importance to the farmer regarding local manufacture of the technology, and also the local servicing capacity for that technology. Economic considerations, such as the ability of the farmer to afford ownership of the technology, was important, and what they would be willing to pay, and also for them access to financing. The ease of use of the technology obviously was important, and this we wanted to make sure included women and youth, and then how safe it was to actually operate this technology. And then finally, what training is necessary to operate the technology as perceived by the farmer. As far as the data collection agenda was concerned, some of this was already mentioned by Dr. Krishnan. So the participants, both adopters and potential adopters, and we had facilitators in terms of graduate students from universities in each country, namely Burkina Faso and Bangladesh. And the target size for the groups was about 50. And each day we set aside about 8 hours for the collection of information. Part of it was an introduction to the farmers or the groups, a field demonstration of the technology, an opportunity for questions and answers, and then the actual filling out of the instrument, where we had sort of 5 people per group of farmers, and together coming up with answers to the questions. And then finally, actual presentations by the farmer groups relative to their questions, and some discussion of lessons learned. The current status, as already mentioned, we have collected some data in Burkina Faso and Bangladesh. In Burkina Faso, we had a group of 64 with 42 males and 22 females. And this occurred in 3 venues there, Hande, Bobodalaso, and Oradara. And then in Bangladesh, a total of 36 people or farmers, 22 males, 14 females. And this occurred in 3 divisions of Bangladesh at Kona, Barisal, and Maiman Singh. And I should mention that the data, as already has been said, the data is being processed at the moment, and we hope to be able to disseminate it in the near future. And of course, future data will be collected from Cambodia and in Senegal as well. So with that, I'd just like to thank you on behalf of myself and also Dr. Ranjani Krishnan for this opportunity to present these details about the scaling gap analysis and the technology readiness assessment. Thank you.
Okay, thank you very much, Dr. Krishnan and Dr. Hansen, for that excellent presentation on the scaling gap analysis and the technology readiness assessment. I'm sure that I know that there's already several questions that have shown up in the chat box. For the sake of time, we are going to consolidate this question and answer period with our last question and answer period of the day. So please hold your questions or utilize the chat feature to ask Dr. Hansen or Dr. Krishnan directly about any questions related to the TRA or scaling gap analysis. But at this time, I am going to proceed to our gender specialist, Maria Jones, and her presentation. Maria is a multifaceted development professional with a passion to empower smallholder farmers, especially women and youth, to access social innovations and services that lift families out of poverty. Maria serves as the Gender and Youth Co-PI for Phase 2 and has been with ASMC since 2018. She has experience with different USAID food security programs spanning program management, implementation, conducting research assessments, and facilitating workshops. Her areas of expertise include gender integration, youth capacity building, scaling adoption of early stage technologies, social enterprise strategy development, and organizational capacity building. Maria holds an MBA from Geese College of Business and a master's in environmental engineering from the University of Illinois. And I will now share Maria's presentation on gender integration.
Good morning.
One last thing before I begin her presentation, similar to Dr. Aryal's, please turn up your volume all the way. This presentation is a little bit on the soft side, so I will do my best to maximize the volume on my end, but I just wanted to put that notice out there. I will now play Maria's presentation. Thank you.
Good morning, good afternoon, good evening to all of my fellow ASMC colleagues. My name is Maria Jones, and I am the Associate Director with the ADM Institute for the Prevention of Post-Harvest Loss at the University of Illinois at Urbana-Champaign. And I also currently serve as the Gender Co-PI with ASMC Phase 2, and I'm very excited to be here today. Over the course of this presentation today, I will address 3 topics. What does the gender strategy for ASMC Phase 2 look like? What are some cross-cutting activities across the 4 countries? And finally, what are some next steps we can look forward to? I want to quickly acknowledge and thank the presenters who've gone before me, who have addressed the gender components in the respective country presentations. Thank you for doing that, because in this presentation, we can now focus a little bit more on the overall gender strategy. For Phase 2 ASMC gender work, I'd like to split it into 2 separate categories. One is what work we'll be doing, and 2, how we'll be doing it. So I'm starting off with the how we'll be doing it. The first thing I want to mention is that there's going to be a major focus on ground level work and ground led work. So we are having in-country gender experts who will be leading activities and the research. Secondly, we will also have some more cross-cutting efforts to integrate gender across the 4 countries that we will be addressing later on, and some capacity building activities and programs that you can request and choose as per your need, and finally an offer for technical assistance. Phase 2 ASMC is able to be country focused because of country experts. I would like to introduce the three experts whom we have right now in each of our countries. Bangladesh, we have Dr. Lovely Mazumdar from the Bangladesh Agricultural University. In Burkina Faso, we have Dr. Salimata Puskar from the Nasiboni University. Cambodia, we are yet to determine the in-country expert, but they will be based at SIIL. And finally, in Senegal, we have Madame Binta Dié from ANCA, the National Agency for Agriculture and Rural Advice. Next, getting into what we will be doing in phase 2. In phase 2, we are going to follow the Reach, Benefit, Empower framework set out by IFPRI. Basically, we're going to ensure that all of our program activities reach women. We're going to then ensure that at least some of the technologies that we are focusing on scaling benefit and empower women, which specifically focus on increasing women's well-being and strengthening their ability to make strategic life choices. ASMC Phase 2 is focused on mechanization scaling. Therefore, in order to ensure that women and men can be reached, benefit from, and empowered through mechanization, we're going to look at all technologies through the technology adoption pathway. This includes technology design, technology dissemination, adoption, and continued use. So to put everything in context, here is a table that lists different activities that have been currently selected as part of our gender integration efforts in ASMC across these two pathways. That is looking at the Reach, Benefit, Empower framework and across the design, dissemination, adoption, and continued use technology pathway. So moving on into cross-cutting activities. In addition to the country-specific activities that you saw in the previous slide, we are going to have cross-cutting activities across the 4 countries. An example of this is gender technology assessment that many of you have participated in phase 1. If there are other technologies that you would like to assess, please do let me know and we can plan for that. And also the scaling up analysis that many of you already know about, led by Dr. Ranjani. In addition, 2 focus areas that have come up from phase 1's assessments and challenges mentioned by you is a need for focusing on women's entrepreneurship within groups or individually, and also looking at training to ensure that training is more gender sensitive, that it can reach women farmers. And I will be providing some capacity building training on this, and I will mention this in an upcoming slide. Now that you know about what our strategy is, I would like to mention about some things you can look forward to. Capacity building workshops. There are 3 different options available to each of you as project coordinators, and I would like you to comment on Zoom if you'd be interested in any or all of these trainings for your teams. Specifically, the first thing would be designing gender-sensitive technologies, where we're going to look at it from an ergonomic standpoint and more. Also looking at developing and facilitating trainings that better reach both women and male smallholder farmers. And finally, training on enabling better adoption of technologies and services by smallholder farmers. So again, please comment on Zoom if you'd be interested in any or all of these trainings. We will also be conducting research within existing project activities to measure the impact and to see if the strategies that we are using actually work to help adoption of mechanization and scale it amongst women farmers. A quick note over here, if you have graduate students who are interested in this work, please let your in-country gender experts know, and please also let me know. This would be great for both a master's and a PhD student. In conclusion, I would say the next immediate steps are to finalize the work plans for the in-country gender activities and to determine what are the capacity building workshops that are needed. I will be scheduling again one-on-one calls with the coordinators of each of the countries to get our next steps moving. And finally, for the different professors who are engaged with ASMC Phase 2, please let me know if you need any technical assistance or any sort of work needed in integrating gender into your activities. Thank you so much, and I'm looking forward to working with you.
Thank you, Maria, for that excellent presentation that you have shared with us. Again, any questions related to this, you can use the chat feature, or we will have a very brief question and answer period after our next presentation, which will be our youth engagement presentation. It is our last presentation of the day, and it highlights ASMC's youth engagement efforts. Dr. George Czapar is the ASMC Extension and Youth Engagement Specialist. Dr. Czapar's research and extension programs focus on addressing the environmental impacts of agriculture. His work includes developing best management practices to reduce pesticide, sediment, and nutrient losses from agriculture. As the former director of the University of Illinois Extension, he seeks to expand the role of extension and outreach to share research results and practical information to diverse audiences. He is passionate about youth engagement and works to adapt the 4-H model for international development. This presentation will also feature a guest speaker. Dr. Samantha Lindgren is an assistant professor of education policy, organization, and leadership in the College of Education at the University of Illinois at Urbana-Champaign. Dr. Lindgren has a bachelor's in astrophysics and a master of education in physics teaching and learning from the University of Minnesota Twin Cities. In 2020, she received her PhD in agricultural and biological engineering at the University of Illinois at Urbana-Champaign. Dr. Lindgren conducted a research study with Dr. Manny Reyes at a high school in Cambodia to measure interest in agriculture in youth. In this presentation, she will explain her research in detail and highlight her findings. I will now share Dr. Czapar and Dr. Lindgren's presentation.
Well, welcome. Welcome. Youth engagement is a very important part of what we do in Extension. And if we could go to the next slide, Leighton, we'll see that Extension has a long history of working with youth. Our 4-H program currently has almost 200,000 young people that are involved. We have the benefit and maybe the luxury that it's been established for a long time. It's been around for over 100 years. And so it's very easy to develop new programs. It's something that when we have a new program like robotics on the next slide, it's easy to roll that out because we have an infrastructure in place. For a country that's just starting out or a program just beginning, it's much more difficult, and it's a challenge because the infrastructure isn't there and it has to really start from the ground up. So one of the things that we are happy to offer to our collaborators and our partners are resources. We can provide information that's Illinois has developed. There's also a national 4-H foundation and curriculum that has some of these programs already ready-made. And some of these are very applicable and can be adapted. If we go to the next slide, there's also an interest in looking at different types of 4-H around the world. There's a global 4-H network that people can look at it and get ideas about how they want to structure their program. And then finally, the next slide shows us that it's not just 4-H. There are other people looking at youth-based programs to involve youth in agriculture that are school-based, that are really not the traditional 4-H program that we think about, yet are very effective. And so the next slide, please, shows you that, again, whatever the countries decide to do and whatever type of program, it really has to come from them. It has to be something that's unique to them. And we're seeing some excellent examples of this currently with our partners in this program. The Smart Agro-Technology Innovation Youth Network that Bangladesh is putting together is really an exciting way to tap into that youth engagement and try and encourage young people to get involved. We have other countries looking at entrepreneurship for rural youth, and that's something, again, that can hopefully involve and excite young people in getting involved in agriculture and other areas that they might find interesting. And then finally, we have some excellent examples coming from Cambodia, looking at high school agricultural technology park. And this is a way, again, to involve young people, to encourage them to see what possibilities are out there and have exposure to really some of the latest information that's available. We're very fortunate that Professor Lindgren has been involved with this effort in Cambodia. And I think with that, Dr. Lindgren, I'll turn it over to you.
Thank you, Dr. Czapar. In 2018, Dr. Manny Reyes and I started a long-distance collaborative research project at the technology park that's at the same location as the Ramsey Sofana High School in Cambodia. Engagement with youth had already begun at this point. So in 2017, there was a no-till garden competition that was hosted by the technology park, and there were many monthly guest speakers and demonstrations. Next slide, Leighton, please. The purpose of the survey was to examine how activities sponsored by the tech park with the school could potentially influence the students' interest in a future career in agriculture. And so we conducted 2 surveys, the first in November of 2018, where we captured about 30% of the school in grades 9 through 12, and then a follow-up survey just a little over a year later, getting those students one grade older. The survey asked questions: demographics, family background, and agriculture, their exposure to agricultural education at school, which included the no-till garden competition and other activities with the tech park, and then their interests in a future career in agriculture. And so on the next slide, we'll see that grade 9 students reported no engagement with agricultural education at school. So they weren't in the school during the no-till garden competition, and they hadn't yet had the opportunity to engage with guest speakers or see any demonstrations. And so in this way, we were able to have them serve as a control group. You can see on the pre-survey that a large proportion of the student populations in grades 10 through 12 were engaged in some of these activities. And then 1 year later on the post-survey, grade 10, which is last year's grade 9, over 90% of them were now reporting that they had engaged in this at school. So on the next slide, we can see that the Likert type scale survey questions were analyzed and a couple of factors emerged. And the one that we're going to focus on today, which is the one that is most related to CSAIN's hypothesis, is student interest in future career in agriculture. So there were a number of questions that asked things like, I would like to pursue agriculture as a career, and then students responded how much they agreed or disagreed with that statement. On the next slide, we see that in grade 9, the students were significantly less interested than the upperclassmen in a future degree in agriculture. And in fact, only 17% of them reported any interest in this as a future career. Whereas in grades 10 through 12 on this pre-survey, those students who reported that they had been exposed to tech park activities and agricultural education were significantly more interested than the students who were not. But overall, nearly 40% of grades 10 through 12 were interested in this as a future career. On the next slide, we look at the post-survey. So what sorts of changes happened in grade 9 now that 90% of them said that they had participated in some of these activities? We see 25% more, or we see a 43% of these students were now interested in a career in agriculture. So it's quite a big difference, statistically significant. On the next slide, there were other predictors that would positively contribute to the students' interest in a future career in farming, including their age and whether or not they work on a farm outside of school. But using these as covariates, we find that these educational experiences with the tech park and at school were still a significant predictor. And then lastly, there are many efforts, as Dr. Czapar alluded to in his presentation, about school-based agriculture, including things like 4-H and more classroom-based approaches, as being a potential way to engage the youth bulge while boosting economic growth in low and middle income countries. But there's actually very little empirical evidence about the effectiveness of this approach. And so recently there have been more calls for work in this area, and hopefully this study can help contribute to that base of knowledge. But it raises some other questions too. So this pre and post survey, the data wasn't matched because we weren't able to get the same students year from year. But if we were, would these interests in a future career in farming be sustained over time? And on the next slide, my last, it also raises some questions about whether or not this would be an effective tool for adoption and uptake for the activities that the tech park is using with adult participants. If we engage their students, are the adults more likely to take up or use one of the innovations that the tech park is promoting? So there's lots of space for future research in this area, and I'm really happy to have been a part of this project and look forward to continuing working on this with Dr. Reyes. Thank you.
Okay, excellent. Thank you to Maria, George, and Samantha for giving those wonderful presentations. I know we're at the time for the end of our general session of the meeting. I know that we have some question and answer periods scheduled, but I don't want to take up too much of your time. So if we have maybe 1 or 2 questions I think we can field those. Other than that, please use the chat feature, and we will try to follow up with everyone who has unanswered questions in the chat at a later date. So at this time, if you do have a question for Dr. Krishnan, Dr. Hansen, Maria, Dr. Czapar, Dr. Lindgren, please feel free to ask your questions now before we wrap up this meeting and adjourn for the day. And if there's not any questions, what I can do is we will go ahead and just begin to adjourn for the day. So, well, sorry, we do have a question from Dr. Prasad.
It's not a question. It's not a question, Leighton,
Okay.
And I appreciate all the folks, lastly, who have been very active in chat and providing the responses. I think I just want to congratulate your team, the leadership of Prasanta, and everybody else who has taken time to present at this virtual launch meeting. I truly appreciate it. And I've learned quite a bit, and I'm excited that the willingness of collaborative spirit in this team, and also the engaging, bringing youth into agriculture and making mechanization as a business and innovations, keeping the innovations at the heart of it. So I'm looking forward to working with you. And as I said in my presentation, we are here to help in any way we can. Our role is to make sure that you don't have any barriers and create an enabling environment for your success. And again, please share your success stories. I know just listening to this, there's so many of them. So please share your success stories and let us be your voice to let others know about your good work. Keep it up. Thank you so much.
Thank you very much, Dr. Prasad. And thank you all for your participation in today's meeting. It has been excellent to hear from all of you and to have you all join us. But I will now turn it over to ASMC Director, Dr. Prasanta Kalita, for his final comments and a farewell address. So thank you. And Dr. Kalita, you may now proceed.
Thank you, Leighton. And my comments will be very short. I'm not going to go into like my last one. I already took my time in my first presentation. But first of all, a big thank you to all the presenters and all the support group, starting from Dr. Prasad, Dr. Jan Middendorf, and also from Dr. Jerry Glover and everybody else, our science committee members. I'm so happy to see the interactions that has been going on in the chat room, all the right questions, and among all the other challenges, time and I know in Cambodia is probably midnight about there, and their whole team is still with us. So I'm really so grateful to all of you. I'm looking forward, one of these days we'll be out of all these difficulties and meet there somewhere that we can look at each other. We can, because there are other things that we can learn by looking at each other, by how you move your hand, how you move your eyes and nose and ears and your dance and all those kind of things. In fact, when there was a music, George and I were actually dancing in my office room because those are beautiful, that Cambodian music to dance into. So thank you so much. Again, Leighton is probably going to very soon. All those sessions have been recorded. We'll put it in our website. And so please stay engaged with all our partners. And like Dr. Prasad says, they are our connection to the USAID and others. Please let us know so we can communicate with them your stories and everything that you have been doing that people need to know, and so they can bring more support for us, more good name for our project, and some recognition for all the hard work that every one of you is working on. So thank you, and all the attendees. I'm so proud of you, honestly. This example was set by our SIIL management with Dr. Jan Middendorf when they did the SIIL project with Zoom, and we thought, we will not be as successful as them, but at least we'll be closer. LB will be 25%. So this is what Leighton did. And Leighton, thank you so much. You did a great job. And there is no words to describe that. So thank you so much, Leighton. Again, I think you might have something else to say, so I'll turn it over to you. And thank you very much.
Okay, thank you very much, Dr. Kalita. I would not have come close to having this meeting without the excellent team that you have put together. And I thank you for that and for your support to be able to conduct a meeting like this. Thank you again to everyone for joining. We will now be having a closed session meeting with our Science Advisory Committee. So at this time, if you are not a in-country project leader or a co-PI or PI, I hope that you have an excellent rest of your day or can finally get to bed if that's the case. I know we've kept everyone up very late in certain parts of the world. So thank you again to everyone for joining. So at this time, the ASMC Phase 2 Inception meeting has come to a conclusion. Thank you all again for joining, and have an excellent rest of your day and week.